इकडे न्यायला लागेल कारण कल्याण तिकडे कुठे झालं
हॅलो मुंगमुडे सर, आवाज येत आहे? आवाज येत आहे?
हेलो हेलो हेलो
Hello. Sir, good morning.
गुड मॉर्निंग
Yes, sir, I welcome you on the behalf of MG College Armory. We are going to start the e-seminar within few minutes.
आपको कल आप लिंक भी देख रहे हैं उसमें आपकी गूगल वाली फोटो भी दिख रही है
आवाज कम क्यों हो रही है?
Hello, sir, am I audible to you?
पास पास रखा था ना इसीलिए उसमें इसमें
उसको बंद कर दो।
खुली है
Hello.
हॅलो. आलाय का? ऑडिओ येत आहे का? ऑडिओ. हॅलो. हॅलो.
हा सर, येतोय आवाज. हो हो. सर बनपूरकर सर, गुड मॉर्निंग. सर अनम्यूट करा तुम्ही.
Okay, good morning.
हाउ आर यू?
That's fine. About you?
ऍब्सोल्युटली फाईन सर.
Okay. अरे सुरू नाही झाली आपली कॉन्फरन्स, अजून व्हायचंय.
हो, एक 2 मिनिटात सुरू करू सर.
ओके ओके ओके, नो प्रॉब्लेम, नो प्रॉब्लेम. टेक युअर टाइम.
तो आप वैसे भी स्क्रीन शेयर करोगे तो बंद नहीं आएगी क्या? वो लगा के देखा है तो हो रहा. एक चीज कर सकते हो, मीटिंग करो ना आप उस फोन पे, तो उसको वो आवाज
हेलो. हेलो.
हॅलो. Hello.
हॅलो मोंगोडे सर. मोंगोडे सर,
हाँ सर.
सगळ्यांना म्यूट करून टाका ना आधी तुम्ही. कारण काही
Mute
आवाज
करू?
येतोय.
हो.
सगळ्यांना, कारण ते आवाज येतात पाठीमागे.
ओके सर.
हॅलो मोंगोडे सर. हॅलो
Yes sir.
सर.
Yes sir.
फक्त जे रिसोर्स पर्सन आहेत त्यांना सोडून बाकी सगळ्यांना म्यूट करू. आणि आपली टीम आणि रिसोर्स पर्सन.
Okay. Okay.
Sunil, my voice is clear to you? Hello, Sunil, my voice is clear to you? My voice is clear to you, Sunil?
Yes, voice is clear.
Fine, thank you very much. So we are going to start our National E-Seminar within few minutes. I welcome all the participants from all around the world. We have many participants from national as well as international level. On behalf of Mahatma Gandhi Art, Science and Led NP Commerce College, Armuri, I welcome you all.
मोंगोडे सर. हॅलो
Yes, sir.
मोंगोडे सर. स्टार्ट करने का है, अभी जो समय हो गया है. You can start the conference.
Sir, shall we start, sir, then?
Yeah, start this.
Okay, sir. I'll just confirm from my technical team. I'll make it start.
Yeah. Okay. Sir, first resource person joined earlier. Dr. Suresh has joined.
Yeah, good morning, sir. I'm there.
Good sir.
Sir.
Yes sir. He's there. Dr. Suresh, sorry.
Good morning to all. With the permission of Principal Dr. Alex Khalsa, sir, I would like to start the National E-Seminar. Good morning to all respected dignitaries and participants. It's my immense pleasure to welcome you on online platform for one-day National E-Seminar on advances in physical and mathematical sciences.
Let me start your video.
Mathematical sciences. Galileo Galilei has correctly said that measure what can be measured and make measurable what cannot be measured. It's a unique and enthusiastic challenge for the science to measure the COVID-19 in form of mathematical expressions. The physics of droplets and its relevance in COVID-19 spreading is the beauty of science which can reveal. The motivation behind this e-seminar is to understand the recent advances in physical and mathematical science in context to cope up with the today's situation. I again welcome all dignitaries and participants. Now, I would like to share some glimpse of our institution. I request my technical team to screen the glimpse of our institution. Over to technical team.
If we want to bring real peace to this world, we should start education. With this philosophy of Rashtrapita Mahatma Gandhi, Manohar Bhai Shikshan Prasarak Mandal established Mahatma Gandhi Arts, Science and Lit NP Commerce College in 1981 in the remote district of Maharashtra, Gadchiroli. Gadchiroli is at the easternmost corner of Maharashtra. It is rural and tribal, where basic infrastructural facilities are lagging behind. To cope up this situation, institution has started 3 faculties: Science, Commerce and Arts at UG and PG level. We have also started a research center in few subjects so that the students from this area should get an opportunity for an higher education. Among all this, we have bagged A grade in 2017 by NAC Bangalore in our 3rd cycle. Apart from that, we have achieved many prestigious awards like Best College Award, State Level Road Safety Awards, and many more. Along with this, our prime motto is the betterment of the students academically, in the concern of extracurricular activities like sports. Some skill-based programs are also started so that each and every individual should get an opportunity to develop their own skill. Along with this, extracurricular activities are a common scenario in our college. Serving the society is reflected in our vision and mission. We organize many such programs to serve the society and to aware the society about many issues. We work from the top level to the grassroots level. Many programs like Unnat Bharat Abhiyan are among our successful stories. Even in the hard time of COVID-19 pandemic, our faculties and our institution has proved that our vision and mission is to serve the society. The prime motto behind the establishment of our institution is the ultimate development of our students. Thank you very much for watching.
Thank you very much to our technical team. Thank you very much for your attention, participants and dignitaries. This seminar is a joint venture of Department of Mathematics and Department of Physics. In our institution, our Department of Mathematics is having two faculties. First, Dr. Lal Singh Harbans Singh Khalsa sir, who is MSc PhD and head and principal of the department, principal of the college, and Dr. Ishaq A. Khan, who is MSc PhD and associate professor. Department of Mathematics offers UG, PG, and we are proud to say that we have a research center of Department of Mathematics, and many of the students has bagged the award of PhD from our research center. The another department is Department of Physics. Here, the head is Dr. R.M. Thomare sir, who is MSc PhD and head of the department, whereas Professor S.B. Gedam, who is an assistant professor, and Dr. C.D. Mungmode, who is MSc SET PhD and an assistant professor in the department. This e-seminar is a joint venture of Department of Physics and Department of Mathematics. And these two departments continuously and consistently strive for the betterment of the physical sciences from our institution. Now, I would like to request Dr. C.D. Mungmode sir, who is the faculty of Department of Physics, to give welcome speech. Screen is over to Dr. C.D. Mungmode sir.
Thank you, Priyadarshana. So, good morning to everyone, and I welcome you all in this National E-Seminar on behalf of Mahatma Gandhi Arts, Science and late NP Commerce College, Armuri, as we raise the curtains of one-day National E-Seminar on advances in physical and mathematical science at this inaugural session being held here today. This seminar is themed on latest advances in research area of physical and mathematical science. For this inauguration session, we have with us Dr. K.S. Nisar, Professor, Department of Mathematics, College of Arts and Science, Wadi Al-Wad sir, Kingdom of Saudi Arabia, Dr. Arun Banpurkar sir, Professor, Department of Physics, Savitribai Phule, Pune University, Pune, Dr. D.V.N.S. Suresh, Associate Professor, Dr. Ambedkar College, Nagpur, Dr. Devendra Kumar Sahu, Professor, Department of Physics, PG Government College, Lalitpur, Jhansi, Dr. Kishore Revatkar, Professor and Head, Department of Physics, Dr. Ambedkar College, Nagpur, Dr. Vinod Varghese, Associate Professor, Department of Mathematics, Late R. Bharti Arts, Commerce and Srimati S.R. Bharti Science College, Arni, and Dr. L.H. Khalsa, Principal and Head, Department of Mathematics of our college. I welcome all the dignitaries, delegates, and participants in this one-day national seminar. Dear friends, we know every walk of our life has been suffered and changed by COVID-19 pandemic. Our education system is no exception for that. But this has created an opportunity to adopt new technologies to communicate with each other. For past many years, our college is striving to bring researchers and academicians together to share their knowledge and expertise and wisdom. In this pandemic situation also, we are organizing a series of e-seminars and conferences on different topics using online platform like Zoom. This e-seminar is a part of the series. This seminar has renowned and experienced speakers who will share their latest research and expertise. Friends, we have got overwhelming response from participants for this national e-seminar. More than 800 participants are registered, not only from different states of India, but about 70 participants are also from other countries like Nigeria, Kenya, Saudi Arabia, Pakistan, South Africa. Due to some technical reasons, we cannot accommodate, we can accommodate only 200 participants on Zoom, but many participants are attending this seminar on YouTube live streaming. I am very thankful to you for showing interest in this national e-seminar. I hope this e-seminar will definitely introduce you the new frontiers of physics and mathematics. In this regard, this e-seminar will be fruitful. Once again, I formally welcome you all dignitaries, invited speakers, and participants in this national e-seminar. Thank you very much. Over to Priyadarshan.
Thank you very much, sir. And thankful to Dr. Suleiman More, sir, who is the faculty from Department of Physics. He has welcomed all our dignitaries and participants. Now, I would like to request our principal, Honorable Dr. Lalsingh Khalsa, sir, to deliver inaugural and introductory remark for this national e-seminar, who is also the faculty and head of Department of Mathematics. I request Dr. Lalsingh Khalsa, sir. Screen is over to Khalsa, sir.
Good morning to all. It's a matter of great pleasure that Department of Physics and Department of Mathematics and jointly organizing this one-day national e-seminar on advances in physical and mathematical sciences. And also we will discuss on the applications related to particularly COVID-19 pandemic. Being the principal of this college, I am Dr. Lalsingh Khalsa. Welcome all the eminent speakers, resource person, delegates, and the large number of participants, not only from India, but also from abroad. I would like to share with you that our college, Mahatma Gandhi Arts, Commerce and Science College, Mahatma Gandhi Arts, Science and Late LP Commerce College, Armory, runs under the flagship of Manohar Bhai Shikshan Prasarak Mandal since 1981. In the various UG programs, UG PG programs, PhD programs, skill-based diploma and advanced diploma courses. And also we run the community college. Our college actually, as per the picture you had shown, that our college is located in rural and tribal area of Maharashtra. But as per our vision and mission, we are dedicated to the holistic development of these underprivileged people. We committed and we are always committed to the community. I am proud to tell you that our college is accredited by NAAC with A grade, and which clearly indicates that how much we are concerned about the quality education. And now looking to the present scenario, we organize, of course, the series of events for the academicians, researchers, students at the national and international level, providing them a platform where one can share their knowledge, wisdom, idea, concept, and contribute in combating the pandemic as per one's own concept and model. So in this regard, today, in this sequence, today we organize this e-seminar. And in this e-seminar, the first speaker, Dr. Suresh, will tell us how to effectively combat COVID-19 through the aspects of the life sciences. With the knowledge of life sciences and medical sciences, he will tell us that what should we do so that we can effectively combat this situation or COVID-19. And our second speaker of the today's seminar is Dr. Vinod, my friend, Dr. Vinod Varghese. And he is collecting the data from life sciences, medical sciences, and currently situation, and is trying to make the mathematical model and present the fractional order model of COVID-19. And definitely this model is very useful to study the effect of this COVID-19 or spreading of this COVID-19 and how to tackle this. And another speaker is with us, Dr. A.G. Banpurkar, who will tell us about the role of physics, particularly in the spreading of disease by droplet and aerosols. Of course, this is a very, very important topic, and I'm sure that this is very useful for all of us, particularly for the researchers and also for the person who is interested, for the policy makers to combat this COVID-19. And another resource person is with us, that is Dr. Devendra Kumar Shah, whose topic is electrical properties of conducting polymer in electric state. And one more, that is a renowned person from Saudi Arabia, who is from mathematical department, Dr. K.S. Nisar. And of course, his topic is how to prepare the quality research paper. And this is really the new researchers need this type of topic because they have to publish some quality research paper of national and international journals. So his topic and his deliberation is very, very useful for all the new coming researchers. And the last one is Dr. Kishore Chandra Revatkar from the Department of Physics, Ambedkar College, Nagpur, will tell us about nanotechnology of its applications. So, looking to all these deliberations and interaction, it is no doubt, it is beyond doubt that physics and mathematics have played and are still playing dominant role in the culmination and development of various technology which are largely affected human life. I believe that today's seminar is going to be the most comprehensive seminar focused on the various aspects of advances in physical and mathematical sciences. Ideas projected in this seminar will be used to improve the situation for human health. I'm sure that deliberations and interactions during the seminar will certainly help in augmenting the research activities and give a new direction to the young researchers. So once again, welcome you all and hope you all enjoy this e-seminar. And I declare the inauguration of this national level e-seminar and hope that it should be the fruitful for all of you. And thank you very much. The screen is over to Dr. Ganveer.
Thank you very much, sir. It was my immense pleasure that you have inaugurated this national e-seminar for the participants. Thank you very much. Now, we will move over to the technical session. Our first speaker is an eminent personality. He is a fellow of Indian Council of Medical Research, and he is an expert in human genetics and cytogenetics as well as fish physiology. He is Dr. D.V.N.S. Suresh. He is an associate professor from Dr. Ambedkar College, Nagpur. And his topic is going to be on COVID, understanding combating in a better way. So I think his topic is the most relevant topic in today's scenario. Now, I request Dr. D.V.
Hello. Good morning to one and all. Am I audible? Good morning, everyone. Am I audible?
Yeah, you are audible.
Good morning to everyone. First of all, I would like to thank the organizers for giving me this opportunity to be one of the physicists and mathematicians. And like being from the biology group, biology side, I would be like enlightening or putting some light on the biological aspects of COVID, which we've been facing now, right now. The COVID, the coronavirus disease 19. So can I share my screen? Get technical support. Is it visible now? Yeah, is it visible now? The screen is visible? I hope.
Yes, sir.
Yes, yes, yes.
Yes, sir.
Thank you, Ravi sir, for introducing me. Like, I have been the researcher associate in the Indian Council of Medical Research, and I keep following the Indian Council of Medical Research regarding the COVID. And I would like to thank all the organizers, all the principals here, and I would not like to mention all the names because if I miss, it would not be good. So all the dignitaries on the main forum, on the board, the online forum, and all the dignitaries and participants, a very good morning. And let's start with some of the biological aspects of COVID, which we would like to know before getting into the physics and mathematics of COVID virus and the disease. First of all, I would like to, I would want you all to see a small clip how the virus gets into our system and how it affects and how it proliferates to the other tissue level. So may I request, and not request, I would say to
Respected Suresh sir. Sorry to interrupt you, sir. Is there a fan in your room because there is a background noise in your voice? Is there something that is making noise? There is a voice, something like fan or something.
Is it okay now?
No, sir. Still the voice is okay.
No, I don't think I have put the fan off.
It is okay now.
No, it's okay. It wasn't a fan, it's an old one, the big one. Yeah, I'm in the department only. It revolves very slow, but it doesn't make us noise as the fans today make. Anyways, I put it up. We would first see a small clip to understand how this virus gets into our system. And for that, a small video clip will be presented. In some trouble. Yeah, it's from somebody else. कहीं और जगह से आवाज आ रही थी. अब बंद हुआ सर. And wanted this. There was a pen which was active and it was writing on the screen. I don't need it. Somebody else is writing it. Dr. Garvey.
Yes, sir.
Somebody is writing on the screen.
No, sir. The screen is not. It is showing that video is unavailable.
It's unavailable.
Due to copyright issue.
I'm very sorry.
It is visible now, sir.
Yeah.
Visible.
Actually, I'm very sorry for this delay. Actually, this was a video from the NPR, the National Public Radio in US, which usually makes people aware of the things which public should know, like about everything about, like in sciences also they give the all they are present in all the media, like in print, in audio, video, media too, and they keep on making people aware of the information which has to be exactly given to, or it has been articulated in the public about anything like disease or happening, or anything which one public should be made aware of. So this was the small clip which shows how this is what the person who has sneezed now, and this sneeze, earlier we used to say God bless you, but now it has become like when somebody sneezes the cough, we say please be a distance from me, maintain a distance from me, you get away from him as he sneezes. Like this is the sneeze in small droplets have come out, and these these crippled things. I have deliberately put them the voice off. These are the viruses which are there, but the person who sneezed was earlier infected with some virus. It's not the coronavirus, but this is just to understand how the virus enters into all viruses have the same mechanism of entering into life system. So now the droplet somehow is inhaled by this person who has been like near to him. And these are the people who have made this video clip for the Clark Wish. His name is Clark Wish. So he made this video for understanding of common public. This is the virus which has come now. And now the thing is, the speciality of this virus again. These are the like key-like structure. These are the spikes. Typical virus has a almost spherical structure. That would come in the next slides, for the slides. And the structure is usually spherical when the virus is small, but it is icosahedral when it is bigger in size. So, but every viruses are similar in having some spiky proteinaceous structures on them, and those spiky structures are sort of keys to get into the living system, to get into the living cells. And these keys are to be matched with the locks which are present on the surface of our own system. So let's see that. So this is a virus with those keys which are resembling the locks which are present on our surface of our cell. These are the throat cells which were depicted here, they were shown here, and these keys match the lock system and the surface of our cells, and then which, as the key fits into the lock, the door is open sort of, and the whole virus can pour its content inside. So like this, the whole content, the whole thing has been received inside. Usually, it's an old video. It doesn't show whether the membrane of the virus gets merged with the membrane of our cell, and the content gets inside. And the content is usually taken in another vesicle sort of thing, which is here they have shown in a different way. So the receiving thing which gets these viruses get inside, and a time comes they have been traveled through the surface of the cell to the interior of the cell, that is the nucleus, along with this thread-like structure, pipe-like structure, rope-like structure, which is microtubule or the filaments. Along with the filaments, these structures carry these ingested viruses, and then the virus ruptures inside because it needs to replicate or duplicate. The which has gone down, I suppose. Anyways, the nucleic content, the nucleic matter now comes out of the viral code, viral cover, and now they enter into the nucleus, where our DNA and RNA are the genetic material, and they usually viruses are of both types, the RNA viruses and the DNA viruses. I would say the DNA viruses were like earlier ones. From there, because DNA is a bit unstable as compared to, RNA is unstable as compared to DNA. So the RNA viruses have transformed or evolved themselves into DNA viruses later. Anyways, but RNA viruses still exist, and they have to be very small to have RNA, because for DNA molecules they need to have a little more space and they become a little bigger in size. Anyways, as they enter into the nucleus, and there, with the help of the copying system, I will not go into the details of that, but with the help of the copying system, those molecules, we call them as polymerase. And these polymerases, sometimes if it's RNA, the virus itself gets the system, the protein molecules, which help in copying the RNA, or which help in copying the genetic material from RNA to its again into RNA log, which it requires. So for that, the RNA has to be first transformed into DNA, and then DNA will be transcribed or translated or duplicated many times, and then again the RNA will be generated, and those RNAs will be now able to produce the. As the RNA of the virus enters into the living nucleus or living cell's nucleus, they begin their copies of their RNA. Whatever the mechanism, but they get we need not to go into the details of that. The RNA is being copied, and the related proteins are also synthesized. And how they're synthesized, simply shown. This is the copying machines, you can say. It's simply a copying machine which copies the RNA molecule which has come inside, along with our own genetic material, the nucleic material. And these copies will now generate the related protein molecules which are required for making the envelope of virus or the spiky proteins of virus. And these mRNA now usually the process is that when the RNA is synthesized, RNA will not manufacture the protein molecules inside the nucleus. It has to come out. So again, with the help of these pores, the RNA comes out of the nucleus, and these are ribosomes. They are called. They are the dishmakers. They are the chefs. They make the protein molecules. They make the protein molecules. These are mRNA entering into the rhythm, and this is the protein molecule which has been made. And they again get into it. And as soon as here, I will explain it later. Now again, the assembly has been done. The protein molecules have been covering the RNA, and now it has come out of the cell as a new virus. So one virus has entered into one cell, and so many baby viruses or duplicate viruses come out. So there was a question in that if so many viruses come out at once, why not this man who has been infected with the droplet die instantly on the place? But it doesn't happen so, because we have got 100,000 trillion cells, and those trillion cells have to be made dead, or they have to be used by these viruses. It takes time, but we have got now the system which helps out in combating this invasion of viruses, and this combat is usually being done by this is what it says. This is some 100 trillion cells in our body, so it takes some time to get. So this is the virus This is the virus which has been like floating in our bloodstream or some other places, some other cavities where it can get into. So we have got this macrophages, those who eat the unwanted stuff, the debris, the kachra of our cell or something which comes from outside. So usually these are the antibodies and the molecules which usually participate in the immune responses. When a virus enters into the system, the signals go on. The signals go towards the virus where they are present. And the way it is the same with the antibodies, the bodies which are fighting against the antigens. That means the virus has got protein molecules around its surface. So as I was told, the spikes are resembling the locks of the protein molecules on our surface. And those surfaces which have these receptors which resemble the viruses spikes, it's okay, but they have got many other molecules also which tell them, many other molecules which usually tell other molecules in the immune system that no, this is not the original own cell. It is something which is coming out from our body. So they have to be like, they have to be consumed. And this is a macrophage. It's a little bit animated. Usually it gets engulfed and once so this was the clip which I wanted to tell you all, and let's go to the presentation. Give me a sec, it's creating a little trouble. So that was a clip which which must have given you a little idea how the viruses usually get inside the living system. First of all, they enter, but if we sneeze or as soon as they have entered and we make a sneeze or a cough, they might come out again. The only thing that when they get attached to the surface with the similar kind of receptors, unless until they match their receptors, they cannot get into. But I will tell you the story how this matching of receptors have occurred. You must have I just tried, like maybe this is a biological aspect of the code which I am delivering before you all. But I would leave the strings for the physics and mathematics to go into deeper side. So these are the the structures, this typical structure of a virus with a spherical cover of which we call envelope proteins, and these are called the spike proteins or the S proteins. And these are the structures for better understanding. This is the coronavirus virus diagram, and this one is, this is an electromicroscopy, in which it shows the coronavirus being it's been photographed under the electron microscopy. And so everywhere, this is a representation of the S protein which is there on the coronavirus, and this S protein has been crystallographed. This is a crystallograph, and the crystallography, of course, it's physics. X-ray crystallography. In X-ray crystallography only helped us to know the structures of DNA. But the only difficult thing which crystallograph creates when you go for imaging the molecules, the newer molecules, it's like the newer molecules. The difficulty is that usually this is the S protein. This is the protein. That means it has got amino acids. If you raise the temperature, the protein molecules will degenerate. The bonds between the amino acids would break, and they would change the structures of protein molecules. That's why we need to have a different type of crystallography. That's called cryocrystallography, I suppose. You are physics. This is physics, and we usually perform a hanging drop method crystallography. In hanging drop crystallization, because for crystallography you need a crystal, I suppose, to get the image. So to make a crystal of those molecules, we need to hang a single drop on the lid of an open top, a small tube which has got a lid. That lid has to be hanged with a small drop of the solution containing the molecule. And that molecule, the hanged molecule, will slowly at lower temperatures will crystallize. And those crystals will be crystallographed. So it becomes a difficult task for biological molecules. It is a little difficult to get the pictures of images of biomolecules. And this is the icosahedral structure, the triangulations, and there's a physics and there's a mathematics behind it. Almost every virus has got this something very related to or near to this structure. Usually they are icosahedral, and the triangulations sometimes follow the hexagonal pattern or sometimes the pentagonal pattern, and depending upon the size of the virus. Usually viruses are below 50 nanometer size. So and at their size, usually they appear to be spherical. And a bit larger, 70, 80 nanometer viruses or more, they are more icosahedral. They seem to be more polyhedral sort of. So there was a reason, or there was an explanation behind it. I don't know exactly what exactly happens, but I have read these triangular surfaces, triangular references for hexameric or pentameric structures, patterns to be icosahedral structure. These they follow. Sometimes these proteins have got their, now in the physics, the elasticity, elastic feature, elastic nature. The elasticity of those protein molecules which uncover the virus or which make the envelope cover, though the elasticity makes it more circular or polyhedral. Anyways, so that was all physics and mathematics, and these are the structures. Like let me take you to another aspect. That is the process. Usually we have seen how the viruses have been. This is the structure, how the lungs are infected, and it's very bad. The white portion is the bad thing, and this is the structure where the coronavirus has been tagged with a fluorescent dye to identify whether they have got the receptors. You can see the receptors here and the color of receptors and the same color and around the virus also. This has been a real feature in some of the workers in US. They have published a paper which shows this. And this another one. This is a picture taken in the fibrotic hardening of tissue of lungs inside, which makes us, which loses the elasticity of the lungs and elevated sacs, the ultimate places where the oxygen or the gases get exchanged. They become rigid, they become fragile, they become non-elastic, and that's where the breathing ability reduces. Anyways, see, this is how, you know, the receptor on the self catches the receptor on the virus, which resembles. This is actually a ACE2, that is angiotensin converting enzyme receptor. This angiotensin has been used in our body, and that enzyme, that converting enzyme is being received here for further metabolic activities. But these viruses have the spikes which resemble the same as angiotensin converting enzyme. So that's why they catch hold of them, and then usually the internalization of viruses take place. See, this is another picture which shows how, you know, these pictures and these videos have been like they are because of the Epoch Times, which Epoch Times has investigated completely in a very extensive way on this virus and the origin of this virus and the people involved behind this. So it was like I'll be touching that part too. So this is how the coronavirus looks exactly as per the Epoch Times report, and this is what, you know, this is another kind of representation of how the viruses get internalized means that is getting into the cell. Now it combines this membrane of the virus combines with the membrane of internal our own cell, and this nucleus contains the RNA which gets into and it replicates and comes out as comes out and makes its copies, the baby viruses. The number of viruses increase, and each number of the duplicative viruses which has come out of that cell, they now infect a fresh cell, because once they come out of that cell is being damaged completely, because it erupts out of it so many times, and the membrane usually breaks off sometimes. And that's what, you know, sometimes if few viruses are coming out, that tissue becomes very inflamed, it becomes very red, the temperature rises there, and as the number of viruses come out of are more than the macrophages which invade and they eat them are less, then we get ill, we get sick. Otherwise, if the macrophages are strong enough to get hold on the number of viruses that are coming out, then we say we have immunity. It's like that. So now little of that a bit of conspiracy, and conspiracy is like, you know, everything started in China. In China, 2010, the Xi Jinping, she was a very good worker. It's her younger days photograph. So she worked on the viruses, the coronavirus. She was the one who identified the coronavirus in Paris, and she was working. She was a dedicated worker. She did not do anything purposefully as they claim. So she did a lot of work on this is she looks like now. She's a bit shut now. She has got many publications in Nature too. And now what she identified the coronavirus in that, and she was trying to manipulate some of the genome in those viruses, the RNA. So she was trying. She was having lack of. This is what the institute is. Where she works. This is the National Institute of Virology, Wuhan, and she started for fundraising programs. Like she visited Europe, she visited US, and she delivered she made everybody, the big scientists and funding agencies, about the work she used to do, and she is doing, and she also projected what she wants to do in future, what she does in future, and that way she could raise many of the funds, and that was there was a increase in funds, and by which she could get a P for lab, Rohan. She could get a P for lab. For that, she had worked a lot. And she could come up with some recombinations in the viruses, And that time we had seen it was recombined with the HIV virus receptors, which usually our system recognizes it. And those receptors will be, the genome related to those receptors have been incorporated in the coronavirus. So the coronavirus, which was clearly infecting the bats, was made susceptible to human cells, human systems. Anyways, so that was like a controversy thing, which was made public by the Epoch Times, a correspondent from Epoch Times who visited, and they could see the whole. I would not go into the details of those the controversial things which have been. I just wanted you all to know about what exactly has happened at that end. And now this is what we all are like combating in a way where we can test the people and we could get like how they are being infected. There are many ways. There's antigen-based tests are there, and the PCR-based tests are there. So we have got options, but the cross-reactivity and the positivity and negative results, they usually now we are getting the information, getting the news that many of the times we get wrong results. But it's not wrong. Once the virus has entered you and it has done its life cycle there, and you have been cured from that, that means your viruses, now you have proper macrophages and the antibodies which could recognize and they can engulf the viruses. They can take control over the viruses in your system. Then it shows. But you have been immune to that. But the viral proteins, the viral RNA, it doesn't get screened off from our body. They still remain some of them. They find some places where they can hide themselves out, and they can come again into action. Like this means these viruses are non-living. They cannot do anything outside the living system. They are as good as particles, dust particles sort of. But when they enter into this living system, they become functional. Particle and function, again the physics. Anyways, so these are some sites where you can find the daily update of how many people are. But this data shows us like we are at a better position. Like the number of people who are getting infected and the number of people are getting cured and they're getting immune and coming back to home is much better than any other countries. Like there's one more thing which mathematics has given us. This is network mapping, network graphs. These graphs were earlier there on this side, but later it's been removed because to avoid the panic among the public. Because these network graphs shows each patient from whom the patient was infected, and the whole network has been maintained. That's the beauty of mathematics and the statistics. Anyways, so biology is nothing in itself. It has to go with physics. It has to go with mathematics. It has to go with statistics. All the sciences included. Of course, biology gives you informational support by which, on the basis of which, you can come up with products or the inventions or discoveries by which mankind would be benefited. Anyways, in the end, we need to, even if in one of my colleagues, my close friends, and Naveed, who happens to be in your college, in your system only, in college system only. So, but when they were discussing something upon the combating system of COVID, so he could project me some aspect of thing which is being in the society, and that aspect is the people who are not aware of these things, when they get a positive test and they've been admitted to the containment centers, and when they're admitted to there, they usually feel because they are immunologically strong. They can beat up the viruses which have been there inside their system, but they don't feel anything. They don't show any symptoms regarding like. You all know it's all been floated in WhatsApp and all social media. What are the features? What are the symptoms which are there when you are infected? So these people who are immunologically strong, they don't exhibit these symptoms. And when they get to the containment areas, where the corona centers, and they see for the next 2-3 days, they don't see any, they don't display any symptom. So the doctors say, take some medicine to reduce the temperature. Now, if at all they have, they don't have no medicines. They stay for 2 or 3 days, and they have been relieved from the center. So that they think that this is not something very serious. They think something is there, which is government is doing something wrong, but it is not like that. You need to understand they are there, and there are many people among us who are more strong, who can fight these viruses. But still, you do not know how strong you are. So you need to keep sanitize yourself as and when required, as often as you do when you're out of home, and please do wash your hands with normal soap when you reach home sufficiently, and keep your mouth covered. Keep your mouth covered whenever it is required, whenever you are out of home, because you never know who is being infected. Maybe he's immunologically very strong, and he could not immunologically very strong, and he may not exhibit symptoms, but he may be carrying the virus. When he sneezes, even if by talking, sometimes some people, spit strong droplets, even those can contain. But usually on the tongue, they don't stay, because we usually flush it out. So flushing it out, cleaning your mouth, cleaning your nose as often as, and keeping our hand sanitation. And of course, the social distancing. We need to follow it. We need to follow it for some other time. Even if the corona doesn't exist, this social distancing is good. This social distancing is good. So there are many physical aspects, and the physical and the mathematical, social and statistical aspects which are related to COVID. And I would definitely like you all to please extrapolate those things which I have suggested, crystallography and the droplet. I have heard one of the speakers, the respected speakers, will be like elaborating the drop infections, the physics behind the drops and all, and somebody who is like will be elaborating the mathematical involvement, mathematical involvement in code explanation. With that, I will put an end to my presentation, and I'm very sorry for the inconvenience caused, like the hindrances caused in between because of the technical issue. In the morning, it was all running fine, but I don't know why it has shown that the video has been stopped because of the public issue, the copyright issue. But it wasn't like that. I had made the cuts of it, and they had uploaded on my video YouTube. It should not have been. But anyways, thank you very much for giving me this opportunity to interact with you all. I tried my little best and to put up some of the biological aspects which everyone should know and everyone should get to know, and left those strings for physics and mathematics which can extrapolate the COVID issue with their own perspective. Thank you very much.
Thank you very much, sir. Thank you very much to Dr. DVNS Suresh, sir. He has rightly and beautifully explained that the way we should combat with the COVID-19. Am I audible to you?
Yes. Yes.
Oh, thank you very much, sir. Now, among the participants, I request if you have any questions, you can just put in the chat box.
Yeah, sure.
Or you can unmute yourself and you can ask it.
Yeah, it is very complex issue as of this coronavirus. So actually, Suresh sir has rightly pointed out some important aspect of how this COVID is actually getting multiplied into a human cell, and that is rightly pointed out. So yeah, most of the questions he could answer. Yeah.
Yes, if you have any questions, you can ask him.
Yeah, thank you very much. I suppose there is nobody.
Yes, sir. I think there are no queries. So if you want to ask any questions to Dr. DVNS Suresh sir, we'll definitely share you the details so that you can talk to him personally if you need any if you need to query about any issue. I request DVNS Suresh sir, if it is possible to put your email ID in the chat box so that if anybody feels to ask something, he can be, he can have a freedom to talk to you.
Yeah, definitely, Dr. Ganveer. I will be like putting my email ID in the chat box. And thank you very much for for you all giving me this opportunity to speak before you all. And I will be very happy to answer if any queries are there. Thank you very much. Thank you.
Thank you very much, sir. Thank you very much, sir. It was an immense pleasure to have Dr. DVNS Suresh, sir. He's an eminent personality and is having a strong hand in human genetics and cytogenetics and a fellow of ICMR. We are very pleased to have you, sir, and we also see the forward endeavor with you, sir. Thank you very much, sir. On behalf of Mahatma Gandhi Arts, Science and Later Commerce College, Armory, and the Department of Mathematics and Physics, we are very grateful to you, sir. Thank you very much.
Thank you very much. Thank you. Thank you.
Thank you, sir. Now, we'll move towards our next resource person. We are very familiar with him, Dr. Vinod Varghese, sir. He is an associate professor in Bharati College, Arni. He's an associate professor of Department of Mathematics, and he is having a sound research experience with 75 international and national publications. And the outstanding fact about Dr. Vinod Varghese sir is that he is an awardee of Prime Minister's prestigious Shram Veer Award 2013. So, and his topic is going to be on analysis of fractional order model of COVID-19 pandemics with non-linear incident rate. So I request Dr. Vinod Varghese sir to deliver his talk. Screen is over to Dr. Vinod Varghese sir.
Yeah, thank you. Good morning to all. Thank you, Dr. Suresh, for your beautiful presentation. And I welcome on this special day, that is 10/10/2020. Okay, this is the day I think it will never repeat. And most of the research area is with the thermoelastic objects, and few papers I have published in Six Sigma, that is on industrial basis. And today, but I have taken a new topic which is related to COVID, and I have tried to go for a mathematical modeling of the simplest model, that is SIR model. Now I'm sharing my screen. And okay, let me tell you, first of all, this paper is already published with Innovation, Biosystem and Bioengineering in Ukraine recently. And myself and one of student of Dr. Lal Singh Khalsa and Nisar sir from Saudi Arabia, we were the co-authors. And this paper I have put forward in the journal in the 25th of June. Later on, it has few revised versions of this. And finally, it was accepted on 7th September. So the topic of my presentation will be analysis of fractional order model of COVID pandemic with a non-linear incident rate. Okay. So my outline will be, I will be initially going with the abstract, then formulation of the model, and one of the extension model of iterative method, and then forecast of pandemic, and finally going with the conclusion. Now, since everybody knows that China was initially infected nation, and when this corona or COVID attack was there, it was an unpredictable virus, and the nature of this virus were not, we were not able to predict. Anyhow, China contaminated all these situations, and they tried in a very well manner. But meanwhile, all that virus has been already spread in the world. So when I was going with this COVID informations, my mind striked what will be the peak at which India will be struck with this virus, and what will be the range of this, how much total number of patients will be infected with this virus. So this was the assumption on which I made this paper. So I have taken a very simple model, that is SIR model. There are other models also. People have made very complicated models, but my intention was to take the fractional order or fractional calculus concept on this SIR model, and to develop a dynamic epidemic behavior of this infected population for India itself. And going with the method which I have developed, I have already told that I have gone with the fractional order SIR model, and I have used the modified Riemann-Liouville fractional differential equation, or what we call as RL fractional differential operator. And these are my few results which I obtained. It was possible to easily to calculate the results, and even I was able to predict the exact peak where this pandemic will be highly affected in India. So these are some of the preliminaries which I have used. First one, I have used the RL derivative. This is RL derivative, and when we are taking n equal to 0, we will get this formula, which one here, equation 2. These are the, then I have taken the integral of Riemann-Liouville integral, and then I have gone with the alternative explanation of RL, that is by using Caputo method. And the last one was the Jumeri's method, and I have used particularly this formula for providing my mathematical expressions. That was definition 2.4. So this is a very well-known equation, which is I think known to all mathematicians and even physics peoples. This was the first equation which was generated by Karmel, and it was in 1927, in which he has published his first paper. And here he has taken three equations. One was the rate of change of susceptibility, rate of change of infectability, and rate of change of recovery. And I have used this formula only, and then using the Jumeri's equation, this is my flow diagram of SIR model, and it is very simplest model. It is very simplest model, and this can be further expanded in with the more complicated problem also. And here this is the S is the susceptibility, infectability, and R is the recovered or recovered. Okay. Okay, now in equation number 7, I have used equation number 7, I have used the fractional order here, and here. Okay. Now my since now we have used this fractional order, and now to solve this equation was one of the complicated way to solve. So one of my colleague, that was Dr. Nisar, he suggested that we can go and use this Lee-He method, in which this fractional derivative can be easily converted into a simple ordinary differential equation. So we have used this by introducing this complex method. We have gone for simplifying this equation number 7. When we have simplified this equation number 7, we got the equation in the form of this. We have got the equation. Now here, this q we were not knowing. This q was an unknown function. So this unknown function has to be obtained. So later on we have found this one. And now this is the initial condition. Initially we have taken S0 as 0, and rest of them also we have taken as 0. Now my question was how to find out the threshold limit. To find out the threshold limit, threshold limit for this sequence, what we have taken this equation, that is we have taken this equation, and this equation we have taken. And but one more thing we have done is to make it more complicated, we have also included the death number, how many people have died, that also we have taken. And we have obtained a basic reproduction number, that is A0, and the number, basic reproduction number which we have obtained was this one, A0, that is R S0 and D plus mu. Now, to solve this equation, we were requiring a numerical method. Actually, we have gone for the numerical method or the approximation method to calculate this one. And for that, we have extended one of the formula which was used by Varsha and Professor Varsha of Pune University and Jeffrey. We have used that one, and we have modified according that it can suit to our problem. And this method was developed, and finally we have obtained the recurrence relation, and this recurrence relation we have taken here, and we have obtained our K-series solutions. Okay, now we will be using this for our formulation, and meanwhile even we have checked whether whatever series we have developed, whether that series is convergent or not. For that, we have used Bhalekar and Varsha's paper, one of the paper in which they have solved that equation by using a contraction method. I have used that one, and found that whichever to assume it is uniformly convergent. And using that and with computer, we were able to forecast, and this was the final equation which we have obtained. And now we will be using Mathematica to explore these equations. And some of the initial conditions which we have taken, is given here. Now we have, since in India, the first attack of coronavirus was on 30th Jan. And we have taken the data, which is easily available in government sites. And the population we have taken as constant, because SIR model says that you can take it as constant. I'm not taking it as a variable. So this was my constant population which I have taken. and the initial infection on 30th Jan was 1, and I have taken this one. And the death rate which I have taken was 7.23 death per 1,000 people. Okay, and the incubation period was, I have taken 5.5, and the contact rate I have taken 19.29, and transmissibility I have taken 2. On the basis of this, I have gone for calculation in Mathematica, and to support my calculation, I have to cross-check that. So what I have done, I have collected the data which was given by Government of India, and I extrapolated that figure, and I have obtained a polynomial curve. I have obtained a polynomial curve. This was only used to cross-check whether our calculation, whatever we are suggesting, whether it is holding true or not. To cross-check, I have extrapolated and I have used this one. Now, when we are taking in fractional order, since the alpha is varying from 0 to 1, less than equal to 1. So as per, if I am taking alpha is equal to 1, it will definitely, it will be true for the initial model which was suggested by Kermark. So I have taken alpha, and on base of this alpha, I have calculated the Indian epidemic features, which in which the total cases and total death, what was the average rate, growth rate for the new cases, what was the average growth rate for new deaths, and like that. This was only based on the classical SIR model. And this was the forecast. This is the moving average. The dark one, brown color, is the moving average, and whereas the red one is the growth rate of the new cases. These were for classical SIR model. And the figure 3 shows the cumulative figure, and it is the historical behavior of the infective cases. Now, moving towards our model, that was the fractional order SIR model. And here I have taken 2 reproductive constants, but A0 as 1.6, which is the, if you think that it is the lowest possibility on which the coronavirus is going to attack, and the highest possibility A0 was, which I have calculated, was 3.86. And for different alpha, we have taken the study, we have conducted this study. And since when we are taking alpha is equal to 1, means we are moving towards our classical model. Now, this is the output. This is the output of the pandemic which we have obtained. The first figure shows that when the A0 is 1.6, and when it was plotted on 350 days, it means near about 1 year complete. When the 1 year will be over, the effect of coronavirus will be attending its minimum. It will be attending its minimum, not exactly 0, but it will be attending its minimum. Means at that time that virus may be weak. Okay. Now another one is when the A0 or constant is 3.86. On the basis of this, again, figure was calculated, and I will show the what was my prediction during this forecast. So when I am taking 3.86 as extrapolated figure, means based on the actual, then I got something. The peak was at something 66 lakhs. And my calculated figure is also showing 66 lakhs. But my calculated figure shows that on 200th day, it will be attending its 66 lakh. Okay, now the question may arise, how much population will be infected? Just double this figure, and approximately we can say that in India, it will be going somewhere 1.30 crores. Nearby populations will be infected by this COVID pandemic. So finally, it was my conclusion in which I have used a new NMI method for calculating and reducing the computational steps and obtain my graphs. And secondly, again, the question arises how this pandemic will decrease. Yeah, again, as said by Dr. Suresh, we have to go for all precautionary steps which has given by the government. We have to follow that. And these are some of the control measures in which definitely we have to obey the quarantine and social distancing. And but as per my model, it says that after the peak, the virus, the strength of the virus will be weakened, and the graph will be start decreasing.
Hello, Dr. Vinod.
Yeah, just I will wind up.
Hello, Dr. Vinod.
Yeah, yeah.
One question in my mind regarding SIR model.
Yeah.
In SIR model, I think there is not mention about the period when the person is exposed to the disease and when that individual actually becomes infected or contagious. This period, when person is exposed and actually,
yes, sir. Yes,
this
yes.
period is not considering in your particularly SIR model, and it plays very
correct, sir. No, that's why initially itself I said that my intention was only to use fractional order for this 3-compartment model. This fractional model can be extended to go for various other models in which we can consider all that quarantine period or infected. There are other models also, sir. So you can use that, but the technique which I have used for SIR model, that can be easily applied on that. This was my intention. Hope your suggestion will be taken for developing my next paper. Thank you, sir.
Good presentation.
Thank you very much, sir. From among participants, if somebody need to ask any question, you can put your question in the chat box, or you can just unmute yourself and you can ask. I request participant, if you have any questions, you can ask.
Priyadarshan, again, I will like to say one thing. This is only a mathematical model, that's all. Okay, so my intention was to obtain the figure at which it can be on the peakest and how much time it will take to wind off that virus epidemic like that. It's approx.
Estimation of all these things.
Yeah.
So, okay, overall good presentation, and definitely in the context of mathematics, you are trying best to show the intensity of pandemic and how it should be controlled. If you know the overall picture of this pandemic, is when it will become at its peak and what we have to do. So this may definitely your results and your suggestions will be very useful for the policy makers also. And in future also we can again modify this paper. So definitely very useful for all of the researchers and policy makers also. So nice presentation, good. So over to Ganvir sir.
Yes, any questions from the participants?
My paper is online available. You can search with this title and it is, you can find that paper. A complete detail is given there.
Okay, I request Dr. Vinod Varghese sir, so you can put your just email ID in the chat box. So if somebody would like to ask questions in future, he can.
I have given that one.
You can just communicate.
During my presentation, last slide, I have given my this one email ID.
Yes,
even if you want, I can share again.
Yes, sir. Just put it in the chat box so that if somebody would have lost or escaped.
Okay.
So this was Dr. Vinod Varghese, sir, an associate professor from Bharati College, Arni, and he is having a vast experience in research with 75 international and national publications, and very rightfully he has explained the mathematical expressions regarding the COVID-19. I'm very thankful to you, sir. I'm very grateful to you, sir, that you came, you gave your precious time to us and delivered your talk with us. I hope my participants would have enjoyed your talk. Thank you very much, sir.
Thank you, sir.
Thank you very much, sir. Now I would like to move for our next speaker. I would like to move to our next speaker. Yes. Dr. A.G. Banturkar, sir. He is a professor in Department of Physics, Savitribai Phule, Pune University, Pune. He is having a vast experience of research, approximately 25 years of research experience. He is a Boycost Fellow of the Department of Science and Technology, Government of India. He is a postdoc fellow from University of Twente, Netherlands, and his topic was physics of complex fluids. More than 60 publications are on his name. We are very fortunate, sir, that we have you in our National E seminar. And his topic is going to be on spread of diseases by droplets, aerosol, physics of droplets from coughing, sneezing, and speech. I request Dr. A.G. Banturkar, sir, to deliver his talk. Screen is over to Dr. Banturkar, sir. Please, sir.
Okay. Am I audible, sir?
Yes, sir, you are audible.
Okay. I shall share my screen now. Yeah. Screen is visible to everyone now?
Yeah, visible.
Okay. Thank you very much, Dr. Mungmode and the team. And I would like to thank Principal Khalsa for setting up such opportunity to have a e-seminar in this pandemic situation. So for all the team, I thanks very much, and they are doing a wonderful job in this, let us say, pandemic situation. Rather than just like sitting at home, they have set up this kind of a, let us say, forum so that we can know each other and we can discuss the research experience among themselves. Okay, so today's topic is spread of diseases by droplet and aerosol, physics of droplet from coughing, sneezing, and speech. Yeah, this is not my exact research topic, but as actually Mungmode suggested that, sir, this topic is this seminar is actually very much blended or very much close to let us say COVID pandemic. So you can put some, let us say, physics part in your, let us say, presentation. That's the reason I blended my research and let us say what actually physics is important, more important in this understanding the pandemic, COVID pandemic. Okay, so the presentation would be, okay, so this is the plan of the presentation. Okay, is it audible and everything is nice?
Yes, sir. Yes, sir.
Okay.
Yeah, audible.
Yes,
Thank
sir.
you. So I'm again going to a very old research. Everybody might have been actually listened to this, heard the name about Brownian motion. Then again coming to a new, let us say, imaging technique by which you can actually visualize a micron-sized droplet by using high-speed cameras and everything. Without actually having a microscope, you can even in a, let us say, ordinary flashlight, this technique is used to image droplets. Okay. Then again, this is droplet, how the droplets is present in a sneeze, what is their distribution, what are their, let us say, fluid dynamics and everything that will be discussed. Again, protection against disease spread. Okay, this is very well known, but again, this might be discussed in a news. But again, I am emphasizing what is the physics, so we should listen to a physicist. Okay. And then at the end, because that is actually we are doing very much research on the microfluidics techniques. So recently, microfluidics techniques is actually immensely used in characterizing or detecting the COVID disease. Okay. Yeah. So this is a slide of Robert Brown. Okay. So actually, he has just like reported, or he has just observed that the pollen grains, when it is suspended in a liquid, they are actually moving here and they are actually performing a random motion. This is very well known. Yeah, this is a textbook study. Okay, and then he thought that because pollen grains are living, then he just like took that because of this living pollen grains, they are actually jiggling here and there. So it is this jiggling in the liquid medium. So he also took pollen grains from a dry flowers, and still he performed, and again he performed the same experiment. He also observed the same thing. Then he again took a dust, which is not a living thing, and put in a water and observed under microscope because he was a botanist. So that time, microscope, all these biology people were using extensive microscope. Then he also observed that the dust is also performing the unseasoned, unstopping motion continuously. Without actually perform or without having external force, because we actually know that the motion is possible when there is a external unbalanced force. Okay, Newton's law. Okay, so this is just a Brownian motion. So at that time, this atoms and molecules is not known. So this study was in 1827. Then actually coming to a work of Einstein, because Einstein is very well known for all this theory of relativity and E is equal to mc square. Okay, but the most, let us say, celebrated or most, let us say, cited paper, his cited paper is actually which is published in 1905 in the month of May, that is on the movement of small particles suspended in a liquid demanded by a molecular kinetic theory of heat. Okay, in 20th century or in 1900, the notion of atoms and molecules were a controversial thing, and then at that time, even you must be aware of it, even the Boltzmann has committed suicide. Ludwig Boltzmann has committed suicide because of these things, because he actually proposes S equal to K ln of W. So the entropy is actually the microscopic thing, and he actually related the microscopic thing to a microscopic particle of a, let us say, gas or let us say liquids. Okay, and at that time these laws was very much controversial. And in the same time, that is actually a different story, and we can have again the different lectures on that topic. Okay, but coming to this Einstein work, the Einstein suggested that actually he proposed that the liquid is actually, or liquid medium or even air or the fluid medium is consist of let us say tiny particle, atoms and molecules. Okay, and then atoms and molecule, they are actually performing, performing a, let us say, or they are actually performing a motion I will go to the slideshow first. Maybe, okay. Yeah. So this is actually zip slide is not able to open. Okay. So here you can actually see that this black actually particles are atoms and molecule of a liquid. Okay, and this yellow actually particle is suspended particle, just like a pollen grains or a dust particle. Okay. So what is happening? Because of the kinetic theory of a gases suggested that you cannot stop a motion of atoms and molecules of a gas inside of a gas or inside a liquid. Okay. So they constantly bombard onto this, let us say, big particle, and because of that, just like that, for example, you are in a crowd. So without having a crowd, and there is because of some stampede. Okay, what is happening that you will be pushed here and there, back and forth, and left and right. Okay, because of that, you will not be on your own position, but you will be drifted to some way or another. Okay, because at the stampede has some motivation, just like they have to come out of, let us say, ground or something. So there is actually directional flow. But your motion, without having, let us say, putting your own efforts, you will be moved back and forth here and there, and you will be pushed back and forth like that. Okay. So actually, the Einstein published 5 papers. One is on, let's say, photoelectric effect, and he got Nobel Prize on photoelectric effect, and some other papers on the special theory of relativity. But this paper is the paper which is actually he proposes that the movement of small particles suspended in a liquid demanded by molecular kinetic theory. He did not even mention the Brownian effect, but this is actually a Brownian effect. Okay, so his explanation was on the Brownian effect. Yeah, coming to the next slide. Okay, so what Einstein derivation? I will not go into the mathematical derivation because currently this equation is defined, or this equation is solved in terms of Langevin kind of equation. Okay, but Einstein did at that time, he used a osmotic pressure relation, and he proposes that let us say micron size particle, yeah, because I am coming to a COVID disease, okay, or COVID, let us say, virus. Okay, now consider my COVID virus is actually a particle. Okay, because I am talking in terms of a particle which is of the micron size. Okay, so whether it's a COVID disease, or whether, sorry, it is COVID virus, or it is just like a bacteria, or it is let us say pollen grains, physics is the same for that. Okay, yeah. So how it is happening? The particle is, let us say, here it is moving, jiggling here and there, and it is coming to this point. Okay, I will show you actual video, then you will realize that how it is moving. Okay, and it is not very complicated thing. In a college like Armory, this effect could be actually seen. You must have been having microscope. So under a microscope, you can see this Brownian motion. Okay, and probably you can actually perform the calculation as well. Okay, so you can actually calculate a displacement. So he suggested that displacement, the displacement for actually classical particle, displacement is defined as velocity into time. So my displacement is proportional to time. Okay, but for Brownian particle, the experimentalist observed that its displacement is proportional to root of time. Okay, and this is very well known observation. Okay, but there was no theory, and there was no just like any theory. So by which this actually experimental observation could be proved. Einstein had put forth this bold step, considering all this medium of the liquid, or the liquid contains atoms or molecules, and he put a kinetic theory of gases and everything, and he come up with this equation. Okay, so I'm talking in terms, I'm talking in equation number 1. This actually theory of this Brownian motion, or the Einstein, let us say, discussion is you will find everywhere, but you can find it on a very, let us say, readable article in Resonance. This is actually a article. This is actually a journal which is published by Indian Institute of Science. Now it is published by Indian Institute of Science, but now it is, I think it is published by Springer. Yeah, but it is controlled is still Indian Institute of Science, Bangalore. Okay, in September 2005. Okay, so in this article you will find all this information. Okay, so he published, or he put forth the 2 equations, because this is a one-dimensional motion. So he took the x square. X square means actually a displacement, and then displacement is given. Now it is here. It's actually proportionality, And proportionality constant is he put in terms of it, just like a gas constant, ambient temperature, Avogadro number, and A is actually the radius of a particle, and eta is viscosity of the gas. Okay, so yeah, so this is the, like, let us say, bold equation he has actually proposed. Or actually 2 dimension, we can take let us say expectation value of x square plus expectation value of y square, because the motion along x-axis and motion along y-axis is independent, so it is probability theory. So based upon that, we can actually derive this equation. Okay. Again, going to the equation number 2, the actually gamma is a dissipation factor that we actually called as the Stokes force, 6 pi eta RV. You know everywhere, because 11th standard and 12th standard even has this experiment on that. And this D is a diffusion constant, which actually which actually has a diffusion, and this gamma is actually a fluctuation. Okay, so it is fluctuation and dissipation theorem is very well known, which is equal to K beta T. That is, K is Boltzmann constant, T is a temperature. Okay, so this is very bold actually statement. Okay, and then he also discussed, he also put derived the equation. I think Dr. Khalsa is well known about this equation, diffusion equation. And then this diffusion equation is very much important in pandemic situation, in financial, everywhere it is now currently, this equation is used. Okay. And the solution of this equation is just like a simple, your Gaussian probability distribution function. Okay, where C is a concentration. Now I am putting in terms of, let us say, 1 dimension, X. Okay, so the concentration of any species, or concentration of this, let us say, micron size particle, if it is started in the starting point is T, okay, is actually following a Gaussian distribution. Okay, and then again it is a diffusion constant D, and this diffusion constant is actually can be written in terms of, let us say, a RMS dispersion. Okay, this is very well understood, and using this equation. Okay, so this is the, let us say, distribution, probability distribution function, very well known, bell-shaped curve. Okay, so this is just like that. One put some like ink droplet in water. Okay, what is happening at that time t equal to 0? The ink droplet will be concentrated at x equal to 0, and as the time actually goes on, okay, it is uniformly spreading along plus x and along minus x. Okay, so there is no actually a bias. Okay, so if there is a flow, then we can have let us say the peak, or the, let us say, the peak will be shifted. This is called as a drift peak. Okay, but the distribution of this, let us say, motion of the, let us say, particle or concentration of the particle follow a probability distribution, Gaussian distribution function. Okay, and based upon this Einstein equation, Perrin used this equation to find out a value of Avogadro number, and then actually he also got a Nobel Prize. And then based upon this Perrin hypothesis, even Einstein proposes that, okay, this is now it is not a, let us say, equation, but it is giving a powerful insight into a kinetic theory of the process, or the diffusion problem. Okay, yeah. So I would like to put one slide here, how it is diffusion it looks like. Here it is actually a starting point. Okay, so Brownian motion, this is actually BSc experiment. Okay, but most of the college or most of even institute, they do not put this experiment, but we can actually perform this experiment at even BSc level. Okay, so the diffusion of particle, that means the dust particle is suspended in water. Okay, what it is happening, it is performing some jiggling motion, and after some time it is end up into this endpoint. Okay, it will not stop, it will again continue, and it will actually occupy all the space. Okay, so if I run the video, how the experimental situation is there.
Okay, so here's our last slide, and you can see the dimple on top of the slide right there.
This is audible now?
We'll take our solution of microbeads with the pipette. And we put a dose of that there. And just gently squeeze that into the dimple. You don't want to use too much, or else you won't get you'll get flow of the beads as they move through the fluid. And you don't want that. So we then take our cover slip, lay it down, then gently just push them into place. And then we can soak up the residue. And looks good. Just place it on a microscope and take a look at the motion. Okay, so we put our slide into the microscope and just the focus of it, and there's our beads. That's all those little tiny dots you see there in the image. There's some other junk in there. I think it's a paper and stuff that I used to wipe off the slide with. But we don't care about that.
Yeah, this is observation under microscope. Low magnification could be 10x microscope.
If we increase the magnification by selecting a different objective and readjusting our focus, we'll see there are beads, and they're still very small, but we can actually see how we can change the focus and look at different depth levels inside that drop fluid. But let's increase the magnification a bit more so you actually see some Brownian motion.
This is observed under maybe 40x magnification of your
just my magnification, I can
ordinary
see
optical microscopes.
They're all jiggling around, and that jiggling around that you see is Brownian motion. So now your job is to pick a good candidate bead to trace its motion and measure how far.
See now, yeah. So these actually beads are jiggling. Okay.
And to do the mathematics that we need.
Yeah.
And it's very important that you choose a good bead. A good bead is going to be one that is isolated. That's not stuck to neighboring beads. That stays within your field of view for the required length of your measurement.
Yeah. See, these are actually a beads. Now it is commercially available. It is called a polystyrene beads. Okay. The size of this bead, it could be 1 micron or 2 micron diameter. Okay. And this is commercially available, not very costly and everything. And if because if you know the size of the beads, then probably if you recall this equation, Einstein equation, because that equation is determined in terms of a expectation value of x square is equal to some constant and t. Okay, so in principle you can actually perform this experiment. You can measure a x square and you can obtain a t. Okay, you can obtain a plot. Okay, it is not very complicated. If somebody is interested, I can share some small project. So she can actually perform experiment at Armory and even other colleges. Okay, so this could be a BSc experiment, very beautiful experiment, and it shows a very fundamental physics, but not only fundamental physics, but it could be able to understand many scientific things. Okay, so what is actually the main thing? For example, this is a bead. Okay, so if you let us say record a movie of this jiggling beads. Okay, what is happening now? There are ready-made softwares are available. As actually we can focus on only one bead. Okay, and how much this bead has been moved, because you know that your video will be recorded at 30 frames per second. Okay, so you know how much time is gone for recording, let us say 1000 frames. Okay, so based upon that time is known. And probably you can calculate, because image processing software is now currently available. So you can calibrate the frame size, or from example, the bead, if you know the bead size is actually 1 micron. So you can calculate, or you can convert pixel in terms of micrometer. And then once you convert in terms of this, once you calibrate the scale, or once you calibrate this video, okay, you can actually calibrate x square. Okay, so such that you probably find out, or you can find out a mean square displacement. Okay, and from the displacement you can plot mean square displacement versus time. Okay, and from the plot the slope is actually giving diffusion constant that contains everything which has been derived by Einstein. You know temperature, you know about viscosity of water and everything. From the simple, let us say, calculation, you can find out either value of the Boltzmann constant K or value of the Avogadro number. Okay, so this is the simple experiment. Okay. Now going to the another, let us say, things, because this is important. Sedimentation. Okay, sedimentation is very well known. Okay, for example, most of the times if muddy water is kept undisturbed, okay, what will happen? The mud will be actually settled down. Okay, because of the gravitational force. Okay, so this is the important aspect. as any tiny particle, let us say virus, it could be bacteria, it could be, let us say, a dust particle. Okay, it is suspended in a air as well as in liquid, and the gravitational force is acting down. Okay, what is happening that the three forces is acting together. A drag force. Okay, drag force is always act opposite to the velocity of the object. Okay, Archimedes force, it is actually buoyancy force acting upward, and gravitational force is pulling downwards. Okay, so it is just like that. My, let us say, wood block is floating on water. Okay, so that is the way the density of, let us say, wood is less than water. That's the reason it is floating. Okay, same way, because some particle, if they are fine enough, okay, yeah, what is happening? They take long time to settle down, and if the big particle is there, they will settle down in a very short interval time. So the classic example is actually a raindrop. Okay, raindrop, it is actually attain a terminal velocity because of the, let us say, equilibrium of these three forces. Okay, so that's a Newton's law again. It suggested that with the bodies remain in a, if the body is not, or the external force is not acted upon the body, then it will be remain in a state of rest, or it will move in a uniform speed. Okay, so that's the reason all these three forces will be acting together, getting a dynamic equilibrium, so that the raindrop will fall with a terminal velocity. Okay, in this case, it's again important, based upon size, based upon density difference, based upon medium viscosity, what is the rate of the sedimentation is important. Okay, so that means how far the droplet will jiggle here and there, or droplet will immediately quickly settle down. It will be depend upon size of the droplet, or the density difference, and the medium viscosity. Okay. Now, coming to our, let us say, this year, maybe it is not hero. Okay, but this is, let us say, troubling things to us. Okay, so this is about a coronavirus. Suresh, the first speaker, has already discussed about this activity of the biological things about this coronavirus. I will go into the physics of that. Okay, whatever maybe it's protein and everything, I will just like to take this is just a particle having some sizes in the range of 60 nanometer to 140 nanometer. Okay, so it has a size, it has this, let us say, some sort of spherical shape, it has a density, so I can just like assume, or I can just like consider this is just like a Brownian particle. Okay, yeah, which is suspended in air medium. Okay. Compare, you can compare this, the size of the coronavirus as compared to the other viruses. It is very much, let us say, small, and it is at the HIV virus, it is comparable to the HIV virus. Okay, but activity is, let us say, vigorous as compared to this all the virus because of this spike protein. Okay, and that is actually discussed by the first speaker. Okay, yeah. So according to the WHO, okay, there are the two regimes. Okay, yeah. Again, this is also the point of view from the physicists' point of view. Okay, then the respiratory infection could be spread by two types of things. Okay, one is when the droplet is of the order of, or it is size of the droplet is greater than 5 to 10 micrometer diameter. They referred as a respiratory droplet itself. Okay, and then again there is another size regime which is less than 5 micrometer diameter. They can call as a respiratory droplet nuclei. Okay, according to the, let us say, current evidence and everything, the COVID-19 virus is primarily transmitted between the people through a respiratory droplet and contact route. Okay, so this is way that the respiratory droplet is actually primary, let us say, source, and the respiratory droplet and contact route is the primary source of, let us say, infection among the people. Okay, yeah. So then this is again the different ways of this is all the protocol which is actually given by WHO. Okay. Another thing is that there is the airborne transmission. Now, airborne transmission means what is happening, something is like suspended very long time. Okay, so airborne transmission is actually dangerous as compared to droplet transmission. Okay, but droplet transmission could be actually you can control, but airborne transmission is very difficult to control. Okay, airborne transmission means a fine particle, very fine particle is remains suspended, and even suspended for a long time. And if it is inhale or if it is going to another body, then this will be infection could be occurred. Okay. Then the COVID-19, they have also mentioned that COVID-19 could be possible, could be transmitted as airborne due to the airborne infection. Okay, And then, but they have mentioned that there is some, let us say, medical condition is there, then only then the airborne transmission is actually is possible. Okay. Now coming to a let us say a paper by MIT group. Okay, it is Lydia Borobia and John Bush. Okay, you might have been seeing this paper in maybe the video of this paper in, let us say, news. Excuse me for that. Again, I am emphasizing paper. Okay, this paper is published in Journal of Fluid Mechanics in 2014. Okay, and this is actually a news which is come up in let us say MIT News edition. Okay. So they performed that, or they actually reported that sneezing produces a complex fluid cascade, not a simple spray. Okay, so as we actually have a spray, our sneeze or our cough is not actually a simple spray, but it is very complex. Okay, as a physicist or a mathematics, complex thing is very important and lovely to model everything. Okay, so they actually try to model this kind. Okay, so they use high-speed imaging, show that how fluid breaks apart in air may help to identify super spread. Okay, then again going to a new topic. So experimental arrangement is simple, but maybe let us say the equipment may be a bit costly. Okay, so here it is a person, human being, or the sampler. Okay, he is actually sneezing, and lighting is arranged everywhere. This is a gravitational field is acting downward, and high-speed camera is actually mounted. Okay, so it is mentioned that it is 1000 frames per second. Even they actually go to the 1 lakh frames per second. Okay, to model the droplet speed. Okay, so then we'll go to the second thing. This is again a video which explains everything. So this is actually Science Friday video. They have, yeah.
Begins with a dusting of pollen, or perhaps a pinch of pepper. For some, a simple glance at the sun can trigger a desperate dash for a tissue. This is, of course, a sneeze, an act that was once believed to be the explosive release of our very soul.
This is actually sneeze. We are not able to see what is coming out of our mouth or our nose.
I mean, if you forget the fact that it is a sneeze, it's actually a pretty beautiful process. Yeah, I think that they're all quite beautiful, actually.
Yeah, is actually in 2014 it was beautiful for a, let us say, modeler or for a, let us say, mathematician to model this kind of phenomena. But now it is very complex, or it is not beautiful, but it is actually giving the evidence, or we can actually, this is actually showing that how we can arrest this kind of a ugly thing. Okay.
Dr. Lydia Bariba is an assistant professor at MIT and a researcher of applied mathematics.
This is complete mathematics now.
Actually, it's really the new frontier to try to understand
problems such as how diseases spread.
We have a lot of work that is done at the cellular level, so interactions between cells, viruses, and tissues, and then a lot of work that is done at the population level, average behaviors, using statistical
to predict rates of infection or mortality. But it turns out there's actually very little research into modeling that moment when my germs become your germs.
There's no history of physical studies that really examine these problems. So what is really contact transmission, and get the physical picture right to describe what's happening when you're actually sneezing. And so thinking about all these things, that's when I realized actually fluid mechanics could help, because when you think about it,
with the help of an MIT colleague, Dr. John Bush, Dr. Bariba set about quantifying the physics of sneezing calls.
As you saw someone sneeze with the naked eye, you would see drops flying out, and they go at whatever their initial speed is, and that determines their range. So in particular, the large drops go further than small drops. Basically, there was no consideration whatsoever of the gas phase.
They call this the multi-phase cloud.
It's really to try to highlight the fact that it's not just droplets being emitted, but there are really these.
Yeah, actually, this is a sedimentation process, a forced, let us say, sedimentation process, and one way it is actually forced from your from your side. Okay, so you must be you can realize that very actually tiny droplets are sedimenting at a very slow rate. Okay, and the bigger droplet are sedimenting at higher rate. Okay. Yeah. So during this time, just like a formation of a droplet, what is happening? It carries viruses and everything. Okay. So viruses, the droplet could contain viruses and everything. Okay. What is happening? At the same time, the droplet is actually evaporating because it is actually made up of water and everything. Okay. So the size of the droplet is actually decreasing. Okay. So that is again ugly thing, because if the droplet is bigger, what will happen? It sediments fastly. But if its droplet is smaller and smaller, or during it is evaporating during the motion, what is happening? It is lighter and lighter. And once it is lighter and lighter, it goes into it can travel a farther distance because of the Brownian motion or because of the diffusion process. Okay. So this is very complicated thing. So one see how it is complicated.
You need to basically have a camera that is not as sensitive, so basically a black and white camera, and then we illuminated the droplets so that the scattered light from the droplets would be projected to the camera. So you have an individual standing there, sneezing, and then you laugh a lot.
Yeah. So this is the way that they have actually modeled that how one can sneezing and coughing. You are actually putting lot of germs and bacteria from your side into an ambient motion. Okay. So even for example, your desk, or for example, your, let us say, surrounding is getting contaminated with virus. Okay. Another thing is there's another research. It is not only by MIT but several groups. Even the Japanese group has actually come up with this similar kind of study, and they actually model the same phenomena, and then see here you can see the how the laboratory looks like.
With a group of researchers.
This is high-speed camera, which could go up to 1 lakh frames per second. And typical arrangement is required to capture this, let us say, droplets.
And a high sensitivity camera. This technology allows us to detect droplets as small as 0.1 micrometers wide.
So that is 100 nanometer detection is possible using this
camera. The experiment starts. First, sneezing. We can see a large droplet about 1 millimeter in diameter. It quickly falls. But let's look through the high sensitivity camera. We can see small particles that seem to glitter floating through the air. These particles are all smaller than 10 micrometers, or 1/100 of a millimeter in diameter. Let's take a look from a different angle. They're small and light. You can see them drifting through the air. These are microdroplets. We're learning that sneezing isn't the only source of these droplets.
Yeah, this shows that sneezing, how it is sneezing is complicated. Okay, so there's a two groups, and there is a one more video because it suggested that your sneezing, coughing, okay, is very much is not very simple, as we cannot actually able to see, or we are not able to see how much droplets we are actually ejecting out of your mouth or nose. Okay, this is also one video by PBS, and here's by Chu Hansen, and he gave of the evidence again. There is another technique, another photographic technique called a Scalorian technique, is used to actually detect the droplets and droplets during the coughing and sneezing. Okay, so I will play this last video.
This is how COVID-19 is spread. Through air currents potentially carrying microscopic droplets full of coronavirus. When we talk, breathe, or cough. We can see this thanks to an imaging technique that lets us peer into the invisible world of airflow. And using this same technique, we can see if masks really do help to stop the spread of coronavirus. Hey, smart people, Joe here. If you've been feeling confused about masks, what they do, what they don't do, whether or not you should wear one, I hope this video will help. And since I'm all by myself at the moment, I don't need to wear this. Why masks work to slow airborne infection. Now, it's important to remember that we can't see viral particles in these images. They're too small, but the viruses are carried on that breath just like a river carries fish. In fact, an individual viral particle is smaller than the weave of most fabrics. So why does this work? Well, masks help in two interesting ways. First, it's important to understand that viruses don't float around alone. They fly out in droplets of moisture. Most droplets are heavy enough that they fall within 2 meters or so. But any person or object would.
This is actually a sedimentation process. The larger droplet sediments faster. Okay.
In that distance can get bathed in virus. And without a mask, some of those droplets can evaporate into super tiny particles of infection that can float on air currents far from your mouth.
Yeah, this is called as a aerosol. Okay, aerosol means again just like a solution. When you actually make a mixed colloidal solution, this is that is similarly. This is actually aerosol. In air, this particle is remain suspended for a long time.
Okay. And these micro droplets are extremely hard for any mask to filter out. But with a mask on, in the warm, humid space between your mouth and the mask, those larger droplets don't have time to evaporate. And they can be captured by common fabrics. If it feels hot and humid in here, that means it's working. And the second way that masks work is that any droplets that do get through now have less momentum. The air currents disperse in eddies and swirls instead of flowing away in streams, which means droplets won't travel as far. So which mask is the best mask? If it seems like recommendations change all the time, that's because doctors and scientists know more now than they did months ago. And they'll know more months from now than they do today, because that's exactly how science is supposed to work. What we do know is whether you're using a bandana, an N95 mask, or a cloth mask you sewed at home, they all still have a lot of droplet blocking power. But that mask has to fit. This is almost like not wearing a mask at all. A mask that's too tight or has too many thick layers can actually force more air out the sides. A good test is to see if you can blow out a candle through your mask from about 1 foot away. These shooter images are clear evidence that masks are effective, but the best science relies on multiple lines of evidence. Here's an experiment that we did with someone talking through a sheet of laser light, illuminating all of the micro droplets released as we speak. With a mask, those droplets are all caught. And this microbiologist sneezed, sang, talked, and coughed over petri dishes. A simple mask blocked nearly all of the germs. And even though this experiment detected bacteria and not viruses, they both leave our airway in the same respiratory droplets. It should be pretty clear to you now why masks work. And the body of research that proves that is getting stronger all the time. Links down in the description. But really, the most important question is, why should you wear a mask? You know, it's often said that masks aren't to keep you from getting sick.
This is very important.
To keep you from getting others sick. Wearing a mask can dramatically reduce the chance of spreading COVID. But that's a strange thing to think about, because you might think, well, I'm not sick. I've got a strong immune system, so I don't need to wear this. But we know that COVID-19 can go undetected. And almost half of infections may come from people who don't show symptoms. That could be you, or it could be the person next to you. And if it is, wouldn't you want them wearing a mask? They probably feel the same way about you. Can masks harm your health with lowering your body's oxygen levels? No, that's a myth, and it's been tested over and over again by healthcare workers who work all day in masks. And masks won't stop the pandemic on their own. They're best used in combination with other safety measures like hand washing and physical distancing. Stereotypically macho people have actually been shown to resist masks more. I get it. Dudes, you don't feel cool. Even.
Yeah, so this is about, let us say, it is a clear explanation or clear evidence that any coughing, any sneezing during cough, during sneeze, or during the speaking. Okay, you are actually ejecting out a lot of droplets, and if that, as actually mentioned, even you are, you may have the COVID, okay, but there is no symptoms, okay, you can actually throwing a droplet out. Droplet out means you are actually throwing viruses out, okay. And as suggested in the video, or it is actually scientifically proved that, okay, wearing a mask is actually very is could very much better, or it is very effective to arrest very effective in arresting a droplet, okay. Because once it is droplet is actually spreading in the air, what is happening, it can evaporate and it can actually form a super tiny droplet, and then the super tiny droplet or nanometer droplet, the ordinary mask is not able to filter it out, okay. So even they have suggested that even if you have a simple cloth mask, okay, just put it on while speaking and while going out, okay. So it is safe for you as well as the safe for me. Yeah. Going to another video. Okay, so this is another, let us say, study which is related to, this is like a water droplets, okay. So when it is water is condensed onto a threads, or water is condensed out everywhere, it is small, actually it forms a very tiny droplets, okay. What's the use of this actually tiny droplets, okay. Here, because of this capillary force, its droplet is formed, and then the formation of the droplet, I'm just keeping out these slides, okay. What is happening, this is a water droplet, and here it is forming some spherical shape, and this is on Teflon surface and this is on glass surface, okay. What is the difference between the two? The water is the same, okay, only on the surface, underneath surface is the different. That's the reason it is in one case it is spreading and other case it is not spreading, okay. This is called as wettability. This is the 12th standard science or even the BSc science, okay. And then this is governed by this equation. This is called as Young's equation, which is determine the wettability, and which is depend upon the, let us say, surface energy of this surface energy between this solid to let us say liquid, or solid to vapor, and it is surface energy of the liquid, okay. What is happening, or what is its role in the modern diagnostic technique, okay. So it is, I'm skipping this slide, okay. This is also, I can skip. This is a nice beautiful droplet on rose actually petal, it is remain stuck, and onto the lotus leaf it is actually easily roll it up, okay. So it is called as hydrophobic surfaces, super hydrophobic surface. Yeah. So coming to a detection of a COVID, what is happening, there are the several techniques by which you can actually the COVID disease is detected, and by which either it is in the form of a blood sample or either in the form of a swab, okay. When this is actually taken to a laboratory, these are the different techniques by which the COVID is actually detected. One of the important technique is actually called as a chip-based biosensor, okay. What is a chip-based biosensor? Okay, we are not aware of with that because we are not actually permitted to enter into the lab, okay. Yeah, we'll get only the report. This is the chip, okay. We know, or we are aware of with the integrated circuit. Similar to the integrated circuit, this is called as a fluidic chip. So on this chip, all the fluid is actually is going in, going out. It is tested, it is braked, it is mixed. Whatever may has to be done, it is actually tested. It is actually operation is performed on a fluid, just like it could be blood, it could be urine, it could be any swab sample, anything, okay. And ultimately, your machine takes a readout, and then it is say that it is positive or it is negative, okay. So yeah, it is fast, low. That's the reason now it is very little sample is actually enough to test your, or enough to conduct your all the tests, okay. So it is fast, it is low consumption of reagent. It is called as a nanoliter droplet is required, sorry, nanoliter volume or picoliter volume is sufficient. Cost effective, less contamination, okay. Challenge, actually the physicist challenge is there, okay. We'll go to the next slide. Yeah. So here you will say that you will actually, you can see that how the fluid, because in this on the microfluidic chip, your samples should be transferred from one point to another point, okay, without any contamination. So this is the liquid droplet, just like it could be droplet of, let us say, blood. Okay, it is transferred from one point to another point, and there are the different techniques. Here, I will play this video. What is happening? Okay, you can actually see how this is actually the size of a droplet is less than millimeter. Okay, so you can see that how the droplet is carried from one let us say electrode to another electrode. Okay, and these are the let us say control circuit. So you can actually transfer the droplet from one point to another. Another important aspect is the mixing. For example, in order to mix, you have a mixer. Okay, but to mix a very 1 millimeter droplet within 1 millimeter droplet, it is very difficult. Okay. So here we are actually working on this kind of problems. Here I will show. Okay, so this is actually a less than 1 millimeter droplet. This is a wire which is, let us say, 20 micron thick. Okay, it is inserted into the droplet. There is underneath some circuit and everything. Now what is happening? There is some action is there. Because of the action, you can actually get a mixing. Okay, so initially it is a dye. It was not mixed. Okay, because the diffusion is very slow. Okay, so it is actually mixed up. Okay, so here this is actually our research topic by which we are actually working on. Okay, so the physics of that, it involves a mathematics as well as physics. Okay, so this is a big droplet. This is not a big droplet, only the magnified. How it is work at? Once you apply electric field between this wire and there is one electrode underneath, okay, below the droplet. What is happening? We are changing the wettability. Okay, so initially it is not wetting. Now voltage is applied. It goes to wetting state. Again, voltage is removed. It goes to non-wetting state. Okay, so this is the basic principle by which you can actually transmit a droplet from one point to the another point. Okay, so discussing a little bit physics of that. It is not a complicated thing. It is called as electrowetting. And here, this is a aqueous conducting droplet. And how it is, this is the electric field which is applied between, there is a electrode, there is a dielectric, and then this is a water droplet is sitting out of the dielectric. Okay, so electric field is applied. The principle is, I will explain the principle. What is happening? So here, there is a charges or charge density getting accumulated at the interface of liquid and dielectric interface. Okay, so this charges, so this electric field or this charge density decreases the surface energy. That's the reason it is wetting. So you can control a wetting by just like applying the electric field. Okay, I'm not going into the details now. This is the equation by which you can again explain the wetting process. Then I will go to another equation. This is the way that you have to characterize the cos theta versus voltage. Okay, how it is actually varying. And then this is where it is having a different application from lens as well as this is windows and everything. And this is where it is now your high definition, your Galaxy cameras and everything that contains a lens which does not need to be moved back and forth, but the curvature of the liquid is controlled by actually electric field, and where this electrowetting principle is used. Okay, then this is okay. So this is our paper. I'm not going into the details now. Yeah. So this is okay. So yeah. So what is happening? Okay. So there is another actually study. You can actually avoid actually the droplet, or what is another way that you can coat the surface with super hydrophobic surfaces or another coating, so that this fluid, for example, which is due to the cuff and sneeze, will not be getting let us say reside there, but it will be getting bounces off. This is called a super hydrophobic surface. Okay, it is not very cost effective because you cannot, let us say, coat your cloths, your, let us say, furniture by super hydrophobic surfaces, but it is used in another, let us say, context where we are actually working. Okay, yeah. So this is now this as this actually disease reminds us. Okay, so in order to, let us say, fight with this COVID, okay, the multidisciplinary science approach is important, where the mathematics, where the biology, and where the physics and even the chemistry is actually working together. Okay, so now in a, let us say, BSc, on BSc level, we talk in terms of, okay, our BSc streams are they different. Sorry, that is mathematics streams is different, physics streams is different, chemistry streams are different. But now it is not actually different, but we have to work together to just like solve the problems which is of physical interest. Okay, so at this end, I would like to say or conclude my presentation. That is, the personal care is important, and the diffusion of the, let us say, droplets or diffusion of, let us say, virus is very important. So in order to avoid the diffusion, or in order to put your droplet from your human being, which is goes into the diffusion state, or let us say supercritical or aerosol state, let us use a mask. That is, we also use a mask and you also use the mask, or we respect each other. So that even I am using a mask, that means I am respecting the other fellow, and other fellow should respect it. Other fellow should use a mask to respect us. Okay, so with this, let us say, word, I'm stopping my presentation, and I would like to have the questions. If somebody has the question, they can actually ask now, or if they want to discuss in detail, they can actually email me, because we are pretty open to all, because we are still working from office. Today we are actually starting our examination. Okay, so that our final examination is currently going on. We are actually providing all the answers paper by online mode and everything. So we are busy from which is working from the department. Okay, so thank you all for listening to the presentation.
Thank you very much, sir. It was a beautiful lecture from your side, and you have rightly explained that how the droplets and the aerosols are responsible for the spreading. Now I request Dr. Siri Mungmore, sir. We have lots of questions about your lecture on our chat box. Mungmore sir has sorted some questions for you. Yeah. So I would request Mungmore sir to ask few of the questions, relevant questions.
Yeah, no problem. Yeah, and even for example, if you have a question, we can discuss in detail, or because we are pretty open to all.
Thank you very much, sir. It was a very nice talk.
Yeah, thank you very much.
Yeah, it was really informative. There are some questions from the participants.
Yeah.
I will take a few of them.
Yes.
So one of them is particles vibrate during Brownian motion.
Yeah.
Is it vibrational or translational motion?
No. It is not kind of just like a vibration. Vibration means actually they are vibrating here and there with the same position. Okay. It is random motion.
Okay.
It is actually random.
Hello.
Yeah. So it is a Brownian motion, not just like it is random motion. There is no control whether they will go into the left side, they will go into the right. It is actually, if you look at, this is a drunkard problem. Drunkard means drunkard. Okay. So if he lost his sense, everything. Okay. And this is a problem of which is actually posed by S. Chandrasekhar. Okay. So where you cannot say that it is just like a translation, or let us say the vibration. It is a combination of that. Yeah. So it is completely random motion. Yeah.
So there was another question from the participant, sir.
Yeah.
If someone sneezes, then how virus spread in air? By attaching with droplets or alone?
No. See, the virus are very small. Okay, virus actually, as the first speaker actually mentioned, that virus comes out with mucus and everything. Okay, so with your all the saliva and everything, with inside the saliva, inside that your let's say body fluid, virus is there. Okay, so even in a video, you can see that outside is your liquid or body fluid. Okay, and inside that there is a virus. Okay, what is happening? Your body fluid get evaporated because it contains water. Okay, then what is left with that? It is virus. Okay, that the viability of the virus is depend upon, I think they mentioned that 7 hour or 10 hour like that. Okay, so even it is falling onto the surface, it will remain as it is. Okay, yeah, and then by that's the reason they are mentioning that if it is some surface is contaminated with virus, and then if you put a hand, what is happening? They will stick to your hand. And then again, if you put your hand to a, let us say, nose, or let us say face, okay, from that the virus can go in. Okay, so the most important thing is that you should not contaminate our, let us say, environment. So that is a good thing, that you put a mask, or even, for example, while sneezing, you can put a, let us say, handkerchief, or there is another way. Okay, there if there is a shirt, then I can just like okay, like that. So you can protect to putting a droplet outside. So this is a respect towards the towards all. Okay, so if you protect them, because this is very complex phenomenon, as you might have been seen through a, let us say, picture high speed video. Okay, this is really because this MIT people and the Japanese people are doing this research. It is not just like a just like video. Okay, it is a real science, and they put forth. They are actually mentioned in 2014 that the infectious disease could be spread by such kind of a violent droplet ejection during sneezing and coughing. Yeah, and then they have actually mentioned the range. That's the reason they mentioned that the 6 feet and everything. But they mentioned that even more than 6 feet, or sometimes they remain in a room. That's the reason they have avoided that. They actually stop the malls. Okay, what is actually stopping the malls means, mall has a air conditioner. Okay, so they are not putting their air out. Okay, just like we have an open window. Okay, so in open window, because I did not show this this video from the Japanese people, there they have mentioned that even in let us say a room with 10 people. Okay, even if you are talking, or even if you are someone is sneezing. Okay, what is happening? The droplets is actually remain in room. They actually circulated through your vent and everything, and your air conditioner filters and everything could not block this. Could not block this actually viruses droplet. Okay, and then this can contaminate whole the, let us say, auditorium or whole room. Okay. Or for example, the mall. Okay. Inside a mall, if one person is sneezing and he or she has a cough, or let us say infected.
Hello, Professor.
Yeah.
होय busy आहे. काय म्हणता?
Yes. Okay. So somebody is actually okay. So if he or she has a, let us say,
किती वाजता meeting?
Okay. So the whole auditorium, whole room could be.
बरं, काय झालं?
That's the reason they stop the malls. Okay. Even we also avoid going into or sitting in a room where there is a closed circulation, because AC has that kind of a thing. AC takes the air from the room, cools it. Again, it is the air is thrown out. Okay. But the filter is not capable. The filter is not just like a 3M filter. Okay. 3M, sorry, in 3M filter or N95 filters are different. There could be another lecture for how the N95 filters are effective. They are effective in actually stopping the droplet, stopping the, let us say, particle which is of the order of few nanometers. Okay, so that's the reason they could even stop the a single virus which is of the order of 60 or 100 nanometers. Okay, so the pore size is adjusted so that they can stop the virus. Okay, but our AC, our ordinary air condition, does not have this kind of, let us say, filters. Okay, so that's the reason we should avoid going into the crowd, or if even we are actually going into the crowd, then we should have a mask.
Okay, sir, there was another question. These particles are very tiny in its nature.
Yeah.
Rather than passing through nasal,
yeah,
is there possibility to penetrate through the skin pores?
No, there is not possible, because see, there as first speaker has mentioned that the skin is actually extracting the liquid. Okay, skin is actually, because the skin is actually oily. Okay, so the problem with our lungs is different, because they have a receptor. Okay, so those receptor is actually, because they have mentioned that lock and key. So lock and key is actually present inside our lungs. Okay, that lock and key is not present onto a skin. Okay, so but they remain as it is. For example, if your hand is getting contaminated with virus, okay, so they remain onto the hand, or they could be remain onto the skin. They did not penetrate. But this disease is actually respiratory. Okay, I'm not actually medical. My profession is not actually medical things. Okay, otherwise, because sometimes even somebody can say that, okay, if I'm eating a, let us say, virus, what is happening? Okay, so some medical, let us say, doctor can let us say about something, because as this respiratory disease, the lock and key is present inside the lungs. So that's the reason it is more dangerous when it is goes into the lungs, but not it is. I think so, but some maybe the answer could be from some medical practitioner. So that's actually reason they are mentioning that you avoid the contact with the nose, let us say eyes and everything. Okay, so at special contact.
Thank you very much, sir. Over to Ganvir, sir.
Thank you very much, sir.
Hello.
Hello. Thank you very much, sir.
Okay, thank you very much.
It was an interactive session from your side, sir, and definitely the number of questions are queried itself shows that the lecture was quite interesting, and they were all curious about many aspects.
Yeah, it is interesting. Brownian motion itself is interesting phenomena. We should actually explore this at BSc level. It is not a very complicated, because if you are interested, we can actually provide the technique or know how it is. It is very simple. Even cell phone camera is sufficient to capture all this.
Thank you very much, sir, that you have given your precious time to us, and you have delivered such a means it is a complex as well as a simple topic and a very relevant topic for us today. Thank you very much, sir. And we also see that in future, again, we will meet in a similar platform, and we would like to listen you again on some another topic. Thank you very much, sir. Thank you. So now, I would like to move towards our next resource person, Dr. Devendra Kumar Sahu. He is a professor in Department of Physics, RS Government PG College, Lalitpur, Jhansi. His expertise is in electronics, as well as he has published over 24 publications in national and international journals. He has guided over 6 research scholars and numerous MPhil students. He is an awardee of Best TEM Micrograph Award. He has also got an award of Outstanding Contribution in Science and Research in 2016. His topic is going to be on electrical properties of conducting polymer in electrate state. I request Dr. Devendra Kumar Sahu to deliver his talk. Screen is over to Dr. Devendra Kumar Sahu. Please, sir. Sir, kindly on your video and unmute yourself. Yes.
Okay.
Sir, kindly start your
yes.
start your video, sir.
Okay. My video is not working today morning. In some problem in laptop.
Okay.
Okay.
Oh, not an issue.
This is my very thankful to the PLH Harsa Principal Sir and his team to join as an invited speaker in the conference on physics and mathematical science. So this is a conference or a webinar on physics. So my topic is electrical property of conductive polymer in electric state. Actually, polymer materials have long been considered to be good insulator because their pro-domain covalent bond exhibit low electroconductivity. However, in Hales it was found that when the linear Collins and heteroatomic polymers were doped by the electrochemical or ion implicance method, their electrical conductivity increase dramatically. So polymers is a Greek word, it's large molecular high molecular weight. They are macromolecules with molecular weight exceeding 10,000 gram per moles. They are also consist of long, repeated, small, and sometimes branch chain built up from some unit called monomers. So we have taken the many types of the polymers, conductant, insulator, and others. So we have taken the conductive polymer that belongs to the important class of cohesive one-dimensional conductor. It can exist and amorphous on a crystal material, but in the most case they consist of the mixture of crystal amorphous. Means that the polymers in the form of mixture of the crystallines and amorphous parts. The main function of the conducting conjugate polymer can easily be tried through careful molecular design and synthesis, giving rise to the various types of the polymer, and specific here we discuss the optical and thermal properties. Actually, the polymers properties can be defined in terms of the energy gap, just like the band gap, because it is working as a valence band and conduction band. So that these conductive polymers are also known as the conjugate polymers. The electronic band gap is related approximately -1 to 3.1 electron volt with corresponding low existence and semiconductor behavior. The polymer is like the conductive polymer. The charge storage properties of the polymer can be considered to modify the emigrating them with some impurities. It means that the net charge mobility in the conducting state is large enough so that high electrical conductivity are applied. Cohesive particle which under the certain condition may move relatively free through the material. The main part is electrochemical doping, because we have the doping of some material, so that the electric conductivity will be the increase. So the electrochemical doping in which a polymer coated working electrode is support. Electrode means we have coated the electrode on the upper surface, lower surface of the polymer, because the polymer cannot be used indirectly. So we have to prepare the thin film or thick film, if the range of the micro level and angstrom level. So the working of the electrode is suspended in the electrode solution, which is the polymer is insoluble along with separate counter of the reference electrode. In other part is an electrical potential difference is created between the electrode, which cause a charge to enter the polymer from the electron, doping just like the N-type and P-type. So the doping is generally two types, P-type and N-type. So we have the conductivity of the polymers and film will increase on the basis of the P-type and N-type. It is the part of the conducting polymer containing carbon atoms, polymer have no carbon atoms. These are two types of the conductive polymers. So we have the use on the polymer containing the carbon atoms, as a alpha-particle polymer, aromatic polymer, and heterocyclic polymer, which is the many types of polymers. The main state, the electric state, is the main important part of our paper. This paper is also published in the Nanovision journals. The dielectric material exhibits the cohesive permanent electrical charge is defined to be an electrate. This is the main important theme of this talk. This implies that the substance will be the electrate if the decay time of its stored polarizations is long in relation to the characterization time of the experimental perform of the material. because the charge complex, the all types of the mechanics related to the polymers is depend on the charge. So the electric field is around this substance around the sample is a constant, so it's also known as the electric state. And the true polarization is usually foreign is the alignments of the real charge comprised of layers of trapping positive and negative charge carrier respectively. Often just is a surface on the surface of the polymer. The charge are behave just like is a electrical properties. We have the four types of the main electrical property, just like the thermally stimulated discharge current, in short form is the THDC, and the other part, other known as other thermally depolarization current. And next is the transient current in the charging and discharging mode. It will also be the follow the current is proportional to the inverse power of the time, and another is a steady state conduction current, and next is the dielectric measurement. So we have to use the some or one conducting polymer. This is aniline. So it is a high flexible, which is make the appearance the manufacturer uses, and it is unique type of the polymer because it is a type of the semiconductor, and it is used the manufacture as a computer chip. It use the chemicals. It can be configured to the conduct across the wide range from the being attractive non-conductive of the insulator use the highly conductive for the other electrical properties. So this is the many types of the thermoelectric, electrostate, radioelectric, photoelectric, thermophotoelectric, and magnetoelectric, and tri-bioelectric. Thermoelectric, there are the prepared by the simultaneous application of heat and an electric field while polarizing a dielectric. And electrostate, this is an electric prepared at room temperature under the application of the high electric field. And a radial field, this is a electric prepared when simultaneously an electric field and a high energy radiation such as X-rays, gamma rays, and beta rays, which is generally used in the radio conditions. Photoelectric, there are the electrons which are prepared by the polarization of dielectric under the simultaneous action of an electric field and ultraviolet or visible light radiation. And another is a thermophotoelectric. There are the electrode which have been prepared by polarization at high temperature, photoconducting dielectric by the high radiation of high energy under the applied electric field. And another is a magnetoelectrostate. This is electric obtained by the coating of the softened or dielectric on the magnetic field. So this is the types of the electric. So we have the discuss of THDC, transient, and steady. This is a main electrical properties as the type of the origin of the charge carrier. Their storage, the transport, the polymeric dielectric are extremely important for the making stable and useful electrodes. So we have to discuss only one electric properties. First is THDC, thermally stimulated discharge current. THDC have been widely used to determine the trapping parameter. Trapping parameter just like is a density, depth, and energy distribution of the trap of the polymers. Just like the THDC aspects of the polymer materials, conducting non-insulator polymers, providing the useful information about the various aspects of the charge storage mechanism, such as space charge limited current, and food Frankel effect and other type of mechanics, because there the many mechanics are also being present in this phenomenon. We had the evolution of the chassis data, just like the identification of the peaks, activation energy, and the relaxation time and charge release. So we have discussed the experimental. It is a very useful to prepare the polymer thin film. So we have used this monomer and oxidation, agent, solvent, and the monomer. So it's a lengthy process to prepare the polymer thin film, where we use this method to first make to the solution of the hydrochloric dissolve 1 mole salt per gram of honeymeal and aniline hydrochloroquine 2 ml of solution. Second dissolve is this potassium dichloride. So we next decide the method of the conductor thin films. The many method to prepare the polymer thin films, just like the thermal operations and combination of internal waffles and flash operation, laser operations, and sputling and vacuum operation, and many methods in the formation of the thin films of the conductive polymers. But the more important techniques are isothermal emerging techniques, because the thermal operation techniques, thin films are the produced from the polymers by thermal operations of bulk material. So the material to be the deposit and heated to be high temperature at a very low pressure and in extremely clean conditions where it's evaporates. This is the process of the thermal operations. So isothermal emergent techniques is the most useful to prepare the polymer thin films. So it is the method of measurement of the thickness of polymer thin films and types of electrode. So three methods of the measurement of thickness of film. This is the mechanical method, optical method, and electrical method. And the types of the electrode is metals, film electrodes, tight electrodes, liquid contact electrodes, and vacuum deposit electrodes. So these are the main instruments. Just like the electrometer amplified is water cantor electrometer is used in the measurement of the current, and high voltage unit is like the vacuum coating unit, and TGA and DSC analyzer, FPR spectral analyzer, NMR spectral analyzer, scanning electron microscopy. So this is my first study in THDC. So this graph also indicates that two peaks, just like a constant electric field, effect of the various polarizing field on THDC rotation of SCL doped lean sample polarized at the polarizing temperature at 40 degrees centigrade with polarizing field. So this graph also indicates two peaks. This first peak is approximately 50 plus minus 10 degrees centigrade, and second peak also represented by 1000 plus. So the magnitude of the current, the maximum current, and the corresponding temperature. So this is the peak current. So this it characterizes consists of the two current maxima. One is lower temperature and other is a high temperature. So this peak is known as the beta peaks at low temperature, and this is the alpha peak in a high temperature. The magnitude of peak current has been found to increase of polarization field. So this field also be indicated by TGR in the next graph. So the activation energy of all beta peaks is almost the same for all depending on the THDC thermogram. so that the phi field value, sometimes the current is decreased in magnitude. The alpha peak, this also so that the alpha peak is shifted towards the lower temperature side and increase the value of temperature. It is also the another graph is the SL peak at just like the temperature, and we have the constant polarizing temperature. We will draw the graph between the corresponding currents and temperature at constant polarizing temperature. So it will also be representing the same phenomena, just the alpha peak and beta peak. So this also will indicate that the alpha peak of the sample also will shifted to the beta peak at higher temperature. So this peak also will represent that the space charge injection injected into the dielectric by the surface breakdown between the dielectric and the electrode, and the space charge injected from the electrode space charge caused by the migration of the charge carrier over the microscopic distance, and the electronic or ionic dipoles caused by the migration of the charge over the microscopic distance. So these are the another graph. For this graph is the log versus by the polarizing field. It will also be the straight line. So the origin of the alpha relaxation process of the peak is confirmed by the fact peak current versus the linearity with polarizing field. So this will also represent that the active energy, as well as reported the alpha peaks many polymers. The trapping in the polymers takes place at the molecular chain, inside chain, and intercept of the crystalline amorphous region of the polymers. And this graph is log I versus the polarizing field at constant temperature. So this graph is on the base of the RMS plots, 10 power 3 upon T versus the log I. It will also be calculate the electric conductivity on the basis of the RMS equations, sigma equal to sigma naught, k power minus the E upon 80, where sigma naught is the periodic factor. So we have defined out the active energy of this material. This is the infrared spectroscopy and some image. So that the same image microscope is doped. It can be seen that the atomic spacing for the doped aniline is 100 micrometer, which is so broadening of the dielectric relaxation spectrum, which increase cross density, rationalized in the terms of large and smaller scale of the movement. And it is also we indicate that the infrared spectroscopy, and this is my NMR spectroscopy. This is the TZ graph. So that the TZ thermogram is two measurement weight loss where screening for the work and lean in which gammas and BP were used to the insulator. The thermogram was typical for the acrylic polymers and thermal degenerations in the form of the depolymerizations, the small peaks at 400 2 degrees centigrade for polymerizations by the radial indicator, and the similar broad peak for the polymer often by the gamma radiation. So that the degeneration of the polymers and the residual polymer also will represent the monomer that we may adjust the cross-linked polymer. This peak is not observed for the polymer obtained by the solution polymerizations. The mean decomposition peak is much sharper and appears at low temperature. the polymer of the solutions. The broad peak of this graph for high temperature is first two figures, so that the higher molecular weight and cross-link in the large dispersive index of the polymers, it is we conclude that the earlier our point, the aniline with dope gas will increase the covalent of the bond and the density of the particle size, which is lead to the increase the electrode size, which lead to the increase the electrical conductivity and the polarization of the THC current. The shape and the size of the THC thermogram is strongly depending upon the polling temperature as well as the polling polarizing field. Generally, actually, commercially available polymer used to the present back is amorphous, and the dopant used is that on donating hydrocarbon groups, which may be the act is the trapping sensor for the charge. So finally, the individually THD relaxation sticks can be also the use of the often various numerous relaxation parameter calculate just like is the alpha p at the polarization temperature 10 so that sorry, this is the active is at peak current on the graph 1 and 2, and the peak temperature, active energy, lesson time, it is also be calculated on draw the graph between the temperature of this current. We also found out this parameter. This is so my polymer quantum size is as approximately 25 micrometer, and electrode is ALL, aluminum system. So this is the electric conductivity and active energy corresponding temperature. Thank you very much. Hello.
Hello.
Hello. Yes. Hello.
Hello, sir. Am I
Yes.
audible to you?
Yes. Yes.
Oh, there was a little technical issue. Thank you very much, sir. This was Dr. Devendra Kumar Sahu, sir, who is the professor from Department of Physics, RS Government PG College, Lalitpur, Jhansi. And he has presented his talk on electrical properties of conducting polymer in electric state. If participants are eager to ask any queries, you can put your questions in the chat box, or you can just unmute yourself and you can discuss. I request participants.
Yes,
Or either
please.
you can raise your hand also.
Okay. We have to write the email on chat box. So you have any queries, so we have to discuss through your email. If any queries?
Okay.
Okay, sir. I request that there is a query, sir. I would like to ask which.
If any query?
I think Munu Upadhyay has raised her hand.
Okay, sir. Okay, sir.
Upadhyay ma'am, if you have any question, you can ask. Sir, Upadhyay sir, sorry. If you have any question, you can ask.
If no question, then please proceed.
Okay, I think there are no questions. I request our resource person Devendra Kumar Sahu sir to put your email ID in the chat box so that if somebody have some personal questions or they want to chat at a personal level,
Okay, sir.
they can communicate with you.
Okay, sir. Thank you, sir.
Thank you very much, sir. Thank you very much. So it was Dr. Devendra Kumar Sahu sir, and it was a very beautiful talk by him. Now, our next resource person is Dr. K.S. Nisar, who is the professor of Department of Mathematics, College of Art, Science, Wadi Aldeshwar, Principal in Abdulaziz University, Kingdom of Saudi Arabia. He has a strong experience of research in mathematics as well as in teaching. He is PhD from Aligarh Muslim University in 2012, and he has published more than approximately it is more than 100 publications are there on his name. And I am very fortunate that you are here, sir. We have an eminent personality from Saudi Arabia. I request Dr. K.S. Nisar, sir, to deliver his talk on how to prepare quality research paper. Of course, you had a strong background of research, so this topic justifies your deliver talk. I request Dr. K.S. Nisar, sir, to deliver his talk. Screen is over to Dr. K.S. Nisar, sir. Am I audible to you, sir? Respected Dr. K.S. Nisar, sir. Am I audible to you?
Yes.
Fine. Yes, sir.
Yeah.
Thank you very much, sir. Screen is over to you.
Yeah. Thank you very much. Let me share my presentation. I think you can visible.
Yeah, visible.
Yes, sir. Yes, we can see your screen, sir.
Okay. So as we are a little late, let me start my presentation without any introduction. As you know that this one is very interesting concept, how to prepare a quality research paper. Okay. One second. Let me continue. One second. There is an issue hanging. Okay. Okay. So my outline of the presentation is know about the journal classification, write an effective scientific research paper, journal selection, develop your skills, and conclusion. Actually, this topic needs more than 1 hour, but I will try to finalize my presentation within time. Okay. There are many things to discuss about this topic because the people, those who wish to submit in a good journal, they have to understand the quality of the journal. The first part of my presentation is journal classification. So in this classification, you have to know about ranking. The first one is International Scientific Institute involved in classification and ranking, that we are saying that ISI journals. This includes the SCI and SCIE journal, then Scopus journal list and master journal list. The most popular classification are, this is indexed by Clarivate Analytics, ISI, SCIE, ESCI, and Scopus SJR. Let me go a little fast because we will discuss the most important part of the presentation after some slide. So these are some basics of this. So what is SCI? As you know, SCI is one of the ISI classification in which the journals are ranked Q1, Q2, Q3, and Q4 based on impact factors. So, you know, first 25% is Q1, next 25 is Q2, and so on. This is the journal classification. Because to write a good paper, you have to know about the journal ranking. To obtain the ranking, one may refer to the Web of Science. So ESCI means this is a master journal list, and these journals are available in Web of Science without impact factors. To obtain the details, one can refer to Clarivate Analytics Master Journal List. Now, you know, Scopus is the one of the most popular database which is ranked by the SJR impact factor. Scopus journals are available in all subject areas in the website www.scopus.com. Now you can see how you can get the information about an impact factor journal. You have to log in Web of Science. After that, you have to type the journal name. Then once you write the journal name, it will show the ranking of the journal like this. You can see here the Applied Mathematics and Computation, its impact factor is 3.472 and the journal rank is Q1. So this is the way we are finding the latest ranking of the journal. Okay. So for ESCI journals, that's also available in the Clarivate Analytics Master Journal List. Okay. Here you can see you will get a different type of journals like Web of Science Core Collections, Arts and Humanities, Science and Citation, etc. All the journals are available here. And actually, journal ranking in Scopus.com, or you can search it by the title, the publication name, or the ISSN, etc. Now, also a private indexing or website is available for checking the quartile ranking of Scopus journal. That is called the www.scimagojr.com. So these are some basic information about the journal classification. Now we understand about the journals. We understand about the journal ranking, impact factors, and different type of indexing. Now we have to think about how to write an effective scientific research paper. Okay. Why research is important? A tool of building knowledge and facilitating learning, means to understand the various issues and increase the public awareness. Research helps people nurture their potential and achieve goals through various opportunities. A seed to love reading, writing, analyzing, and sharing valuable information, nourishment, and exercise for the mind. So those who are new in research, I mean those who are research scholars, they have to understand, they have to plan their research is based on these points. Okay, instead of just achieving the degree, they have to think some mental exercise as research. How to organize a research paper in a good form. Now we are going to discuss the main points of the presentation. So the first one, a comprehensive title. The title must be comprehensive. An informative block of abstract. Rich introduction by citing all the related research papers based on the relevance of the topic. Main result and discussion including analysis, conclusion, and a well-structured bibliography. So these are the core points of preparing a research paper. So we will start from the title. The title must be clear and attractive. Second one is an informative block of abstract. Okay, the abstract is in block by including all the information about your work and a rich introduction. We have to cite all the related research papers based on the relevance of the topic. Then after that, you can add some analysis part like simulation analysis, numerical analysis. Then the paper must end with a conclusion. Now, see, I would like to say something about abstract writing. An abstract is like a movie trailer. People will watch considering the reading the rest of the manuscript if they find your abstract is interesting. Okay, so abstract must be very attractive. If your abstract is interesting, then the readers can continue their reading. Abstract offers preview, highlights key points, and help the audience decide whether to view the entire work or not. Abstract are the pivot of the research paper because of many journal editorial boards screen manuscript only on the basis of the abstract. So abstract is very important. And if your abstract doesn't grab their attention and not make a good first impression, there is a good chance your research paper will be rejected at the outset. So you have to plan your abstract in a perfect form. Moreover, even after your research paper is published, your abstract will be the first and possible only the things readers will access through the electronic searches. As you know that if you are targeting the non-open access journal, then the readers can only find the title and abstract with the keywords. So these things are very important. The readers will only consider reading the rest of the manuscript if they find your abstract is interesting. So write the abstract after you have finished your work. Okay, this is one technique you have to improve if you want to improve the abstract, you can write the abstract after completing the complete paper. Pick out the key statement from your introduction, methods, and discussion section to the frame your abstract with the logical flow. So you can collect the main point from the different sections like introduction, methods, result, and discussion. I can give you some example how to write the abstract. So here I would like to say some points which must be avoided. First one, undefined abbreviations or group of names. So sometimes we are using some abbreviations in the abstract without explaining the thing. So it is better to avoid that. And you must explain you can give these abbreviations in the introduction section. A discussion of previous literature or reference citation. Unnecessary details about the methods used. So it is better to avoid the references in the abstract. Also avoid saying the previous work. Some researchers did this and that. All this information must be in the introduction. In your sentences to ensure that the information flows well. Confirm that there is a consistency between the information presented in the abstract and the paper. Okay, there must be a connection between the remaining part of the paper and the abstract. Ask a colleague to review your abstract and check if the purpose, aim, methods, and conclusions of the study are clearly stated. So after writing your paper, you may discuss with your friends of the field so that he or she can suggest you more about your scientific writing. Check to see if the final abstract meet the guidelines of the targeted journal, like word limit, type of abstract, recommended subheadings, etc. Maximum journals, they have instructions for authors, so you can read it before submitting your paper. Now revisit your abstract with these steps in mind, and here you will be able to revise it and make it more attractive. Another thing you can do is back to some of the most interesting papers you have read during your literature review. Don't be surprised if you find that they also happen to have some of the best abstract you have seen. So you can compare your abstract with other existing good paper, then you can improve your paper better. Now you can see sample of a good abstract. This I found in the journal Applied Energy. You can see they mentioned what must be included in the abstract section. First, the objective. Okay, you can focus something like that. You can start with the objective, then methods, then result, conclusion, and practical implication. So this is an example of a good abstract. Means these things must be there. The objective, methods, and the part of result must be highlighted. Conclusion and the practical implication. Now you can see my suggestion is that the abstract should contain subjective, methods, result, conclusion, and practical implication as suggested above, but it will be better to write abstract in a single block and avoid small titles that subtitles as shown in the sample abstract. So you can include all these things without highlighting these subtitles like objective methods. No need to highlight such a type of subtitles. Just you can write the block of abstract without mentioning that. Now see main body of the paper. It must contain recent development of the subject and cite all the relevant papers. Mention the structure of the papers at the end of the introduction section. Okay. Second is main result. Explain all the result as in detail and easy to follow. You know, sometimes what we are doing, we are giving the tough. We are skipping many steps and we are just giving the main result without explaining the terms. This will be very difficult. We need readers, and readers must understand our work. This will make your paper is more readable. Analysis. This part is the most attractive part of the research paper. Give as much figures and tables for visual impact. So this is another very good point. If you can prepare your paper with a visual impact, it will be very good. And the conclusion, it must be summary of the above findings. So in conclusion, you know, people are used to repeat the abstract. I think it is not a good idea. Conclusion must be different from the abstract, and it must be the summary of the our finding. And reference section, all the information must be correct and accurate. Sometimes we are using short name of journal, some reference we are using full name of journals. So it must be accurate. Means if you are following style of the writing, then you have to follow the same for all the references. Now you can see journal selection and submission. I am talking a little fast. If you have any difficulties, please inform me. So journal selection, first what you have to do, you have to read the aim and scope of the journal before submission. This is very important because sometimes you are writing a good paper and you are targeting a wrong journal because you are not reading the aim and scope of the journal. So first you have to read the aim and scope of the journal. Structure your paper based on the aim and scope of the journal. So there must some, there are many classification keywords in the journal. So you have to focus in that keywords, and you have to include it in your abstract or title so that you know the editors can understand this paper belongs to the scope of the journal. Subject classification. Check the subject classification from your journal website. Choose the most suitable classification from journal website at the time of submission, or keep it in mind at the time of preparation of the paper. Some journals demand first two keywords classification must be from MSc 2010. This is I am talking about mathematics. If you are working in physics, then there are keywords for physics. I don't remember the short, but different there. Okay. For mathematics, this AMS classification 2010 and 2020. Now, editorial board member, check the availability of the expert in the editorial member in the editorial board, or we can say that specialist from your subject area. Many journals are asking to choose the editor, assign the paper based on the keywords. So we must check the editorial members related to the work. If no subject expert available in the editorial board, then it is not advisable to submit in that journal. So we have to search some expert of subject from the journal so that you know your paper can handle very easily by that person. Now, suggested reviewer name. Many of the journal are giving the opportunity to suggest the reviewer. If you suggest the subject expert as reviewers, then their comments will help to improve the paper in good form. You know what we are doing? Maximum time we are doing that we are suggesting the name of our friends. But you know, unfortunately, the editor will not consider these names because he will look for the name of the experts in the field. So it will be better and it will be good option to suggest the name of expert in the subject area so that you know that comments will help to improve your paper in the revision stage. Now this is the final. I am little quick. I just want to motivate you how to develop your skills. Okay. So now you understand about the journal classification. You got an idea about the journal and you got an idea about the journal selection. Now you have to prepare a paper. You know, you got everything, all the information about the abstract writing, introduction writing, and selection of journals. So now you have a picture in your mind. Now you can see, I would like to explain or share my experience with some research paper, how to develop your skill. You know, this is very interesting part for me because I am discussing with myself. For example, let us start with this is an example. Those who are research scholar and those who are working actively in research, it will be a motivation for them. Now you can see, everyone know those, everyone in the science background, they know about metrics, okay? So you can see this is a simple matrix, that is, we know that 3 identity matrix, okay? Everyone know this. Now what's the application of this? What is the application of this in a different field like engineering? Now you know that I would like to connect this thing with the optical communication, okay? So let me, you know, in optical communication, or we can say communication, we are considering the binary coding like 1 and 0. Okay. So here, see the development. So I am not going in deep. So here you can see these are some example. I don't want to go to this. Actually, this is about metrics in communication and just arranging some 1 and 0s, or we can say binary coding like this. Okay. So in engineering, you know, in metrics, we are calling that row 1, row 2, row 3, and so on. But, you know, in engineering, the engineers thinking like this: user 1, user 2, user 3, and user 4. Okay. So here you can see this one is the code weight. Okay. Those who have some knowledge about optical communication, they understand this. But my intention is to explain the development. Now you can see from the metrics, here you can see this is called zero cross correlation code because there is no intersection between two users. So this is flexible cross correlation code because there is an intersection between two users. So now I would like to explain from here. Now you can see this is very old triangle concept, pattern concept, which was invented in 1653. That we know that it is Pascal's triangle. Okay, so you know Pascal's triangle means starting from 1, and the first row is 1 1, then 1 plus 1 2, that is 1 2 1. Everyone know about Pascal's triangle. Now see, while I was referring this Pascal's triangle, the idea click in my mind. Okay, now you can see here. One second. Pascal's triangle code. Okay, Pascal's triangle code. This concept was published in 2018. What I did, I just replaced the numbers by unity. That is 1 1. Now you can see the pattern 1 1, and all other elements I took as 0 to get the binary pattern. Okay. Now here you can see, here also 1 1 1. Then all other quantity other than the diagonal passion. You know, if you are considering the Pascal's triangle, you will get some matrix pattern like this. Okay. Now, interestingly, I developed a general form of Pascal's triangle matrix with the binary numbers. That is 1 and 0. Okay. So I developed this in the form of binary matrix. Okay. And this is a general form of binary Pascal's type triangle matrix. Now see, this is if you look the Pascal's triangle, you feel that it is very simple. There is nothing. What I did, I just replaced these numbers other than 1 is 0. Like this 2, just I replaced this 2 by 0, 3 by 0, 4 6 4 by 0. So all elements other than 1, I just replaced by 0. So this is the simple concept. Okay, I just want to motivate you how to develop your skill. Now see, what is the result? The result is that we published a paper that's called Development and Performance Analysis of Zero Cross Correlation Code using a type of Pascal's triangle matrix for spectral amplitude coding, optical code division, multiple access network. Now you can see a simple concept give me a good paper. So that's why I'm saying, if you have, suppose that this matrix concept is very popular with everyone. So small things you have to use a concept. Now you can see another one that is, I call it as GMPC, that is Generalized Matrix Partition Code. This matrix partition code developed by myself, and this patented in 2018. I got a patent for this work. What I did, I just developed a form of matrix, okay, that is in different fashion by considering many properties. So you have to understand the properties, you have to read that optical communication related work, okay. So here you know what the congestion, I just increase the number of users in diagonal fashion. Like, I just consider as first group is G1, then G2 and G3. So after that, I proposed some transformation process with the different users. And what's the result? You can see the result. I published a paper in 2017, and it called as Numerical Construction of Generalized Matrix Partition Code for SAC OCDMA system. So you can see there is a simple concept of matrix pattern, but developed with a good impact. Okay. So there are many. After that, I just consider the anti-diagonal type matrix. The matrix with anti-diagonal. Diagonal matrix. I started with diagonal matrix, and now I am talking about anti-diagonal matrix. And I just use one technique called the switching pattern, and I call this method is called NZCC, New Zero Cross Correlation Code. And using some technique, based on the properties of the code, I just developed this coding pattern. And see the result here. I got another paper called Construction of Zero Cross Correlation Code using a type of anti-diagonal identity column block matrix. So I have, my PhD is in special function and fractional calculus with umbrella calculus. I have no such knowledge. I had no such knowledge before about how to connect my work in engineering field. But you have to read. You have to understand the recent development of the engineering field. So I just start reading with the very small concept. I know that okay, matrix is very simple. Let me focus on the matrices. Then I just start reading on matrices. Then I tried to connect with my interest to the engineering field. So I got many papers. So that's why I said everyone have the skill. You have to develop the skill. For your understanding, I will show you one or two slides. Then I will finish. Okay. Now you can see I got another paper also for NZCC. It is published in a very good journal, Photonic Network Communication, with my friends from Punjab University. Now see, those who are in master's student or PhD, they are very familiar with the Jordan block matrix. So in Jordan block matrix, there are block with eigenvalues, okay, lambda 1. So while teaching this in my class, I just focus that, okay, if I replace this eigenvalues lambda by 1, then I will get the binary pattern. So what I did, in the Jordan block matrix, I just replaced that eigenvalues by 1, and I developed a generalized matrix, and I got this generalized matrix. You can see now the main diagonal is 1, followed by the another block of 1, and this switching pattern. This is I just developed based on according to the need of the code. Okay. So what's the result? The result is we got the good paper that we call it as DEU. Diagonal eigenvalue code, eigenvalue unity code for spectral amplitude coding, optical code division, multiple access. So the concept is very simple because the concept is about the Jordan block matrix, and it is very familiar. Jordan block matrix. So nothing we did, we just replaced the eigenvalues lambda by 1, and after that we developed some switching pattern. After that we got the paper, and it is published in one of the top journal, Optical Technology. And recently we developed another work using this DEU code that's published in Optic. So you can see a small concept to give many good papers. So finally, I think you got some motivation. So finally, I have to say Not that your paper is a bride, so make up accordingly. Okay, you have to do the big effort to make the paper is perfect. Do the makeup as much as possible. Everything must be perfect at the time of first submission. Many good papers are get rejected due to the bad structure and poor English language. So you have to be very careful, not in hurry. That's why I always suggested you to work in a team. Now, at the age of 38, I am full professor because, because of hard work, I published a 400 plus paper, and you can see maximum are in top journals because, I have different group. I always motivate my team, and I learn from my team. I motivate my students. I help my students. The teamwork will give you the good paper, and you have to discuss with your friend without any selfishness. Because once you preserve yourself that no, I have to publish myself, then you cannot produce much. So different minds will give you different ideas. So you have to discuss with your friends and you have to work in a team. Then you will get more papers, more ideas, more quality research. So you have to go like this, okay? And finally, the paper must be well structured and error-free. A suggestion: the authors are suggested to read the aim and scope of the journal before submission. Structure your paper based on the journal demand. The paper must arrange simply so that the readers can follow the result easily. If you wish to increase the citation, then you can go with the open access journal, which is openly accessible all over the world. So these are, there are many things to discuss about, papers, journal classification. The people are thinking, the researchers thinking that, okay, we know this knowledge, but, there are many motivation behind this. How to catch the journal, how to work together, how to produce the quality paper. There are, this will give the, you will get from the experience. So these points are very important and you have to focus it, you have to focus on it and you have to work as a team and then you will produce the good papers. Thank you very much. I think in the short time, you understand something. If you want more, you can contact me anytime. Okay. Thank you very much.
Thank you very much, sir. I'm thankful to Dr. K.S. Nisar, sir, Professor, Department of Mathematics, for a beautiful presentation. And I think it was the much needed presentation for the academic world. I appeal to participants that if you have any query, you can put in the chat box or you can raise your hand or you can unmute yourself and talk. And I would like to tell Dr. K.S. Nisar so that many of them are asking for your PowerPoint presentation. But I would tell all the participants that this presentation is always be stored on the YouTube link you have. Whenever you want to refer it, you can just go to the YouTube link and you can just refer it. So there is no need of the presentation. You just go on the YouTube link and you can just make your own notes. So if you have any queries, just you can put your queries. Yes, I request participants.
I want to talk about Nisar's presentation. It's really very, very excellent and very informative, particularly for the young researchers. And really, it is very, very useful. And you are telling some criteria is required to publish the qualities, and it is helping for the new researchers. And you are talking about you have to be a quality resource. Definitely, this is a very, very useful, and I am particularly thankful to Dr. Nisar sir, who is accept our invitation and giving such a useful lectures, particularly for our research scholars and our new generations. So thank you, sir, and hope that in the next time we will expect some new topics from you and connect with our students or our professors, young professors. Thank you, sir.
Okay, sir. Thank you very much. Thank you very much for inviting me. Actually, we have the time difference, so I was waiting for morning, so that's I am little hurry. I have another webinar and many things are there. So next time I will take my own time and I can explain more. and I can share my experience. I think this presentation will motivate many, because I started my research from the scratch, because this is a different field, and I developed myself the very interesting things. So I think many will try to develop their skill. Thank you very much, sir. Thank you very much.
Thank you, sir.
Thank you very much, sir. I am very grateful that you have given your time. Thank you very much.
Okay, well.
Now, we will move towards our next resource person. Yes. Our next resource person is Honorable Dr. Kishore Chandra Revatkar, sir. He is the professor and head of Department of Physics in Dr. Ambedkar College, Nagpur. He has a vast experience of teaching as well as research. He specialized in spectroscopy, ferrites, crystallography, etc. He has guided 27 PhD scholars and more than 100 publications on his name. And he's also a 3 distinct patent holder. So it is an immense fortune for us that being such an eminent personality, you gave your time and you
Hello.
Sir, there is some technical issue. So I invite Dr. Kishore Chandra Revatkar, sir, to make his presentations on nanotechnology and its application. Over to Revatkar, sir.
Okay, thank you very much. Thank you, Dr. Khalsa, sir, old friend of mine, for giving me an opportunity to share my views and ideas regarding the nanotechnology. Basically, I started my teaching career or teaching profession from a Mofussil area, which was then associated with RTM Nagpur University. Now that college is belonging to the Gondwana University, and still I am in association with Gondwana University as a member of Board of Studies. And while I started my career, let me share a few things and then I will start with the presentation actually. So I started working on some material which was not basically a nanomaterial. It was something else that why not to start with something else. And slowly my guide has helped me a lot and taught me many more things that we can do in Indian perspective, you can say that, because we are lacking somewhere. So that thing has definitely been there, that we do not have access to a good laboratory or good lab, but still we can do some wonderful work, because in my last some 20 years of journey, I started from, as I told you, from Ganesh Mahavidyalaya in Orgaon, and presently I'm working in Dr. Ambedkar College as professor and head of the department. And in my this 20 years of journey, a lot of publications I did, a lot of conferences we have organized, and a lot of patents we are developing. Almost 11 patents are we have registered from my laboratory, and that too is undergraduate college. It's not because we have got a lot of high-tech instrumentation. No, that is not the case. Even that kind of the instrumentations are not available in the universities also. But if you develop an attitude and the right approach toward the research, then many times I have seen that Indian students or Indian teachers or faculties from the colleges keep on crying that we don't have access for the good instrumentation, we don't have access for good library, we don't have access for this and that. But I don't think research is only been framed in the four wall. It is beyond that. Only thing we have to think over that. So I thought this is very important because many of the participants in this conference are from a faculty, that is a teaching fraternity, and maybe a mixed mob is there. So I thought that it is the right time for me to share, being a senior person, you can say that. So let me start with the presentation. So I'm starting with my presentation. Yeah. So I'll be talking on nanotechnology applications in science, engineering, and technology. But I'm not going in the technical details of all these things. Few things which I'm sharing from my lab, and things are there already, and we have planned to reach over that. But as I told you, that for doing a good research work, because before me, one speaker has spoke about how to write a good research paper. That is also one of the areas where we Indians are lagging. Lot of things are there, but if you systematically do this kind of the work, then definitely one day you will land in good publications also. But ultimately, I can say that I can suggest you that don't go directly for the research publication. If you really your research work is good quality, a standard quality, then go for a patent, and then later on you can switch over to publications. So that is my intention. So let me start with the presentation. So the one who is a host, please admit these people, because that is disturbing me a lot. I don't know whether I'm audible or not. Okay. So let me start with a little general thing, and then I will switch over to my work. So we all know these people. These people actually have contributed a lot, are the base of, you can say that, the modern science. But many of these people do not get a good laboratory. They have developed their laboratory on their own. And we know that, like if you take an example of the Steve Jobs, who was the founder of the Apple phone, who has started something like that, and now Apple is having some quality or having a standard gadget. So that is, it is because they have put lot of work, they have put lot of research behind that. Many times we get confused between the research and the discovery, and many faculties I have seen that once they get PhD, they simply stop that. Now enough is enough, now I cannot move forward because I have this thing. So a lot of 100 type of the lame excuses we are putting forth. Now after Professor C.V. Raman, who has received the Nobel Prize in 1930 for the Raman scattering, few Indians are there, but they are all you can say that they were all the non-residential. Of course Venkataraman is here. So what require for excelling as a good researcher is something which I think which is been required over there. So like the right kind of the attitude, and if you have perception and creative this and that, then definitely we can do some good research work. So now this is not the problem for my or you people or many other people. This is the problem of the kind of the attitude, the kind of the mentality that we Indians are bearing. Now, if you see the scenario, that international scenario where we are standing in a number of documentation that we are filing, that is a research paper or something like that, patent, as you can see that. So somewhere where we are lying, even we do not have that much of the thing, you can see 0.1. So if you see the other countries, the European countries or other countries, you can see their index is something like 73, and where we are standing here. So a 0.1. So we cannot compare that. And even the quality wise, if you see the international scenario and the Indian scenario, so this is where we are standing here. On the science graduates, you see number of 1,000 populations. If you consider 1,000 populations, in New Zealand. So where we are here, so when we consider 1,000, so we are comparable to them in 0.84. And likewise in other areas also see researcher per 1,000 population. So we are 0.02. So in 1,000, Finland is having greatest number. So if we consider their 1,000 person, then we are 0.02. Even we are not in a one number. And likewise, the same thing will be here. And likewise, the scientific publications, if you consider, this is a few countries we have considered. So let us consider our neighboring countries who has given the gift of the coronavirus for us. And this China, who is every year, you can say that globally they are publishing something like this number. Then 5,28,000, and we are having like this 1,35,000. This is the number of publications. We are not even nearer to them, though the number is looking like that. But if you consider a situation 10 years ago or 15 years ago, not more than that, 15 years, the China and India, we together were standing on a platform, on a same platform, on the you can say that on the research perspective I'm talking. Okay, so we were same, but now they have surpassed, even they have surpassed the United States also, which is supposed to be the technologically advanced country, but it is not so. The picture is very poor picture. And if you see, we are having the third largest scientific and technical manpower. We are saying that we are having the young blood, largest young power. But where this power we are utilizing, that power is not being properly utilized. That power, manpower I'm talking, is not being channelized properly. So we need to think that. Now India is going to enter an era of education. Now we are shifting towards the new kind of the education policy that Ranganathan has given. But do you think really that we are in a position to accept it? We are in a position to explore that kind of the thing. So we are talking about the 21st century. But it doesn't mean that we Indians are duffers. There are a lot of young bloods. You can see the name, you maybe probably know, the Red Bus, who is a founder, the Phanindra Samant, who is a really young chap person. You can see Bhavesh Agrawal, who is a co-founder of the Ola Cabs, and so on and so forth. Make My Trip, an Indian founder. These are all Indian bloods. These are all Indian brains. But why we are not having that global recognition is only, I think, is because of the right approach and the right attitude. Many times, as I said in the previously, that it doesn't matter how we do a research we have. Many times we can say that there are a lot of things. I have seen so many laboratories wherein the good instrumentations that has been procured, but they are covered. Even their plastic that has not been wrapped up. There may be a situation in your college also and in my college also that many times we do invite because of some pressure from the management or principal that no, you should have to carry out the research work, and then we just procure an instrument. It is been kept covered and it is been kept covered and covered and covered, and after 5 years, when some enthusiastic faculty or students ask the teacher who is in charge of that covered instrument, then they said that no, it was purchased some 5 years back, now it is of no use. So why we are wasting that kind of thing? We do not know how to use them. It will be never be enough, like that the picture is rightly pointing out that this is how we can think that. And many times we do carry the heavy loads of thought in our head. Only we are carrying those thoughts, but we are not trying to materialize it. This is why I'm telling you, I'm not just giving a philosophical lecture to you. This is what I'm giving you. This is what I'm sharing my own thoughts, because I have seen. So how you have to grow, not as a lecturer because we are getting a salary, and nowadays the UGC has given the recognition to the college teachers as a professor also. But do we really think that we are of that caliber of the professor? Do you think that is a $1 million question? We have to think over that. But we should think over that. So, and by thinking that if one or other, if really be an honest human being, one should think about doing a research. Because why I'm telling this, in the last 4 or 5 months, I have given so many lectures. After the lecture, I have received so many queries, so many questions that how to patent a file, how to do a research paper, where to go, where from we get this and where from we go that. And after 1 or 2 query, once the participant receive their certificate, then the questions get vanished and nobody even think of contacting this, that even after giving the email ID and this and that, nobody is bothered about that because we want the ready-made kind of the thing. But my dear Indian friends, Indian faculties, Indian friends, and maybe some foreign people I have seen there in the Google meeting at present, this Zoom meeting. So please do something else, and it is been required for us. So with that, let me start with this. So there are when we say nanoparticle or nanoscience or nanotechnology, so now nanotechnology or nanoscience will be spreading their wings like anything in almost every walks of life. Everywhere it is being there. It was not a new technology, it was a old technology, but maybe because of some constraint in the techniques, constraint in the technique, or constraint in the technology, that was not being explored, that was limited to certain areas, certain aspects, but that I'm not going to talk about that. So this is what you can say, that nowadays at present, this era is a nano era, you can say that, wherein there are a lot of applications in environmental science. Renewable energy is one of the critical or the area which need a lot of concentration. The textile is another area. Biomedical science, the nanoscience that has been flourished a lot. Health science, food, agriculture, industry, and so many things are there. So this slide you may be knowing. So why this slide is important is that if you start with this, that a decimeter or a centimeter, wherein there are few things, a material which is we are considering at a bulk level. So bulk level material, and when we come down to a smaller size, to the atomic size, to the molecular size, to a nanometer, and even there is a scope, there is a lot of room at the bottom, as been rightly pointed out by Richard Feynman. And people are exploring now the nanomaterials, nanoscience, you can say that. So it is, you can see the picometer is another area wherein we can think about that. So why nanomaterial is so important? Because one of the properties of nanomaterial is high surface to volume ratio. This is what we are teaching at the BSc undergraduate level. But how really we can visualize this, that how the surface area and volume, these are the only two properties of a material, same bulk material, but when surface area that has been increased, it is having a wonderful properties, and that is what the nanomaterial. So one such property, earlier, maybe 10 years back, we have seen most of the times when our Indian cricketers goes to Australia or to the New Zealand side, they used to coat their surface with this kind of the white kind of the powder form. It was nothing but a simple zinc oxide nanoparticles. Zinc oxide particles, you can say that, which are white in color. Okay, so these nanoparticles do have, so what was the purpose of that? It was the only purpose of that was to block the ultraviolet radiation. You can say that the ultraviolet light. So this ultraviolet light can be blocked down, but nowadays still these cricketers, those who are playing their sports in the sun radiations, a high temperature, even at present this IPL is going on in Dubai and then Sharjah and Abu Dhabi, but that is going in during night hours. It is only because a lot of it is there. But still in the daytime when they play, they are coating, still coating, but that particle, you can say that is a nanoparticle. So nowadays, so that is why these nanoparticles are transparent. So you cannot judge it whether your face that is coated is only because this, and it is simply a nano zinc oxide, जिसको हम just बोलते हैं zinc oxide. So that zinc oxide particle that has been processed, brought down to a very small size, nano size, so which can be helping to have the blocking and then scattering the visible light so that you can keep your body to be cool. So likewise, nanotechnology that has been, there are a lot of areas where this is one of my area where I am working on a magnetic material since my PhD work. I continued it for almost last 20-25 years. So I know that the magnetic material earlier they were used only as a hard magnet. But now if you take an example of your car, at present today's car, then there are about 36 different kind of the small or larger parts in the car which are using your magnets. Okay, kindly remind me about the time. If I exceeding the time, please remind me. And then from that we started, and today we are using this nanomaterial as an application to treat the cancer patient. And that technology is known as the magnetic hyperthermia. Even we can deliver some kind of the drugs with the help of the magnetic material. So, and it was possible only because of the nano size. We know, those who are physicists, those knows that what is the multi-domain. When we consider the ferromagnetic material, then we have a multi-domain wall wherein the small nanomagnets, atomic nanomagnets, being separated by a certain wall that is called as a domain wall. And now from that multi-domain, we have come to a single domain. So from that BH curve, if you consider this BH curve, wherein there is a loss in the energy, BH curve or hysteresis loop, you can say that. So from that loop, so we have come to a kind of the loop which is only something like a single line. A single line is there. So magnet can be, a material can be magnetized and it can be demagnetized. So while magnetizing, the energy that has been absorbed by the material in the form of magnetic energy, when we demagnetize it, when we reverse it, when the reversal of the magnetism that will take place, then it will be releasing all that energy. And that kind of the material is called as a super paramagnetic material. And it is because of the single wall. So here we can have a multiple wall, and then we can have a single wall. You can say that only single domain is there. So this single domain, super paramagnetic material, which is a non-magnetic, can be demagnetized at a desired temperature. So, and that temperature, you can say that is something about 45 to 51 degrees Celsius, which the temperature that a normal human cell can bear. Beyond that, the cell can burnt off. So that material are called as the spions. You can say that super paramagnetic iron oxide nano materials, that is called as the spions. Then we require, these are the requirements that can be achieved in the laboratory and can be treated in this case. So timeline for development, just I'm a little bit talking about that application of nanotechnology. So earlier we used to have the external treatment of the body cells, but now we can penetrate this nanomaterial inside the cell. Then we can correct cell by cell. It is not necessary that if a patient is having some kind of the cyst, a cancer, you can say that, and which is required the operation, now it can be avoided, because once the patient goes through the operation, so there are a lot of side effects are there, this and that, many things are there, but the patient can be operated, that particular part of the cancer cell can be removed down with the help of these hyperthermia applications, and intracell also, so that the normal cell cannot be destroyed. The treatment, there are kind of the treatment, conventional treatment for the cancer therapy is to treat with the radiation, high energy radiations, you can say that. When these radiations been exposed to the body, then with the cancer cells, because there are certain cycles the patient has to go, some 25 times one has to take the radiation dose. So that is called as a dosimetry. And because of that, the patient has a lot of problems. And then there are another kind of the treatment that is called as a chemotherapy, wherein some chemicals that has been injected, given injections, chemical injections being given to the patient, so that this chemical therapy has its own disadvantages. Some side effects are there, like vomiting sensation, loss of hair, baldness, and this and that. So many things are. But that can be avoided with the help of. So thanks to the nanotechnology. Then this is another way by which the magnetic material. So what it has been done, like a capsule. So we know the doctor will give you the tablet and the capsule. So capsule is a kind of the coating is there material, which is the edible coating, you can say that. And inside that capsule, if you break down some capsule, you find out the actual medicine is inside in the form of a powder or in the form of a small granules. So likewise, we can prepare a spiral course. So why prepare a spiral course? So that the core, and inside that core, you can see the medicine is there. Inside this, you can see the medicine or the drug is there. So what does it do? That will act as a carrier. Now then, how you can insert the spions? What is so special about that? These spions are magnetic material. These spions are magnetic material, and these are biocompatible materials. So because of that, what will be happening? That when this material that will be inserted, because it is a nanomaterial, the size is very small. The nano size, which is smaller, very, very small than the size of your vein. So even you can say that smaller than the red blood cell. Red blood cell se bhi chota hoga ye. So that is easily been taken, and we know that inside the body, the whole part of the body will be carrying the blood everywhere. If there is no blood, that part will be dead. So with the help of the blood, that can be flowed down, and this kind of the dendrimers or dendrils that will be attached to that, so that will help in floating through the blood. And then once it reaches to the particular part where we have to deliver the medicine, then that will get attached there. Accordingly, the other parameters like the pH value, maybe the biology side students can understand this. The pH value that will be adjusted accordingly, and once it reaches this cover of the core, that will be broke down, and the medicine that will be released. So this is a simple way. This is one of the utility model regarding, as I told you, that if the tumor is here somewhere where the appendix side is the last part of the you can say that our digestive system, then it can be localized, it can be checked, then it will be activated externally with the magnetic field, and then the medicine that will be allowed to pass, send it to, transport it to that particular part. Then once it will be reaching to that part, then it will be broken down over there, and then the drug that will be delivered. And then once the drug is delivered to that particular part, so what happening that because of that, the other part of the body will not get affected. We are saying that we are delivering drug means it's a chemical. So this chemical you have later one side effects also. So instead of getting whole body exposed to that particular chemical where it is not being required, so that side effects can be minimized. So this is what the maximum uses of that. And then there are so many applications of nanomaterials. I'm just keeping that. Now another application of nanomaterial is a microwave dielectric. So we know that if I take an example of our mobile phone, so earlier we used to have a black kind of this strip toward the brim of your mobile brim or mobile periphery. You have the black strip. That was your antenna. Nowadays, you can see the concept of infinity that has been developed. From this particular end to this particular end, completely that mobile screen will be spread over that, and it is only because of the development in the antennas, in the patch antennas. So this normal range of the C-band resonator, if you can see, is something about 700 megahertz to 1.5, or rather 2.5. That was for the 3G, and if you say for the 4G, then it is something like this 2.5 to 4, that will be the gigahertz frequency. Okay, and 5G it will be having a more frequency. So in this frequency range, if we develop certain dielectric material, so physics people can understand what is the dielectric material. That material is an insulator material at a normal thing, but when they are being pass through an electric field, they can develop the polarity on both the sides, and then that polarity can be used for the resonance. So that is what called as a dielectric resonance. And then this dielectric resonance can find out the microwave and millimeter band, because the dielectric resonators are smaller in size, so nano size dielectric resonators we can use. Then we can have a large bandwidth that has been increased. So because of which we can have the 4G. Now we are expecting a 5G to start, and likewise that it is because of these dielectric resonators. So these are some of the antennas. I am skipping them. Third kind of the applications of this magnetic material we are using that is on the solar cell. Now the earlier solar cell is a silicon based solar cell, silicon or germanium solar cell. But now we can have that means a single crystal silicon cell, we can say that is a solar cell, wherein there is a substrate on that single crystal silicon cell, silicon junction that will be developed, and then that can be exposed to the radiation. So because of the radiation, the electron hole pair that has been created, and then the electrons will be taken away, it will be stored as a charges, so we can use as a solar cell. But the conversion efficiency, conversion of the light radiations into the electrical signals, or into the, you can say that the into the required electricity, that conversion is only 17% or even less than that. But if we use certain multi-cell or multi-layer crystalline cells, then it is observed that the efficiency that has been increased to up to a 21 to 24% efficiency. Even a 1% increase in the efficiency, that is the great achievement. So that can be done with the help of that, and we have developed such a solar cells wherein we have expected that this is what I have done in my laboratory. That is why I am telling you that this can be possible, and these solar cells we have tested it, and some solar cell materials we have patented also from our lab, so that can be giving a 21% efficiency. And then there are different kind of the applications of the nanomaterials are there. One such application is we can go to a DNA level, we can go to a RNA level, and we can even repair the cells inside the body by sending this, so that if there is some defect, so like there are certain autosomal kind of the diseases are there, which are passing from the one generation to next generation, that is from the parents to the offsprings. So that can be stopped. That corrections in the DNA can be done with the help of the nanotechnology. Even a single molecular transistor that can be developed, and one of such scientists is Sumit Mazumdar. Of course, he is an Indian name, but he is in USA. He has done that. So that is possible. And there are a lot of applications of the solar cells are there. So of which we can have the transparent solar cell. So my request to the host, shall I continue or shall I stop?
Continue, sir. Continue, sir. Continue.
Continue for 2 minutes and 1 minute.
Yes, yes. Yeah.
Because basically I am a teacher.
Okay. No problem,
so
sir.
I will finish it up in 5, 6.
Okay, okay, sir. Okay, sir.
Yeah, because I am the last person. I am the last person.
Yeah.
I have that freedom of taking some.
Okay, sir.
Thank you very much. So the main component in the material, the same fluorine, which is available in plenty of number in your cultural area. We are affecting the water is in fluoride water. So that we can develop the fluorine from that, and that can be dosed with the. And what is the the speciality of this kind of the glass is there is that they are transparent. We can use for the window sheet, but at the same time, your glass window, if it is generating the electric power for you, then definitely it will be helping you, and it will be reducing your electric bill. It will be reducing this MSNDL, Maharashtra State National, what is that name has been changed, MSAB2, whatever that name is there. So your window panels can develop because we are living in a tropical area where there is almost the sunlight for 10 months. Hardly we can live for the 2 months. So 10 months we are receiving the sunlight, but we are not converting that sunlight into the useful form of the energy, isn't it? So we can make use of these panels, window panels, door panels, or can have a rooftop with this kind of the glass, which are toughened glass, strong glass, and then they can generate the electricity for us. So then that is one of the greatest ways. So that is possible with the help of the nanotechnology. So then there are a lot of uses of nanotechnology there. Is something it leads to the economic growth. And today we know that because of this pandemic situation, the economy that has been on the verge of the collapse. So we need to develop this kind of the things so that we can help, and then even a national security and leads to the job. So a lot of things are there. Carbon is one such material which is available in plenty form in your Gadchiroli area. That range of this, wherein we can do use of this carbon material to develop a desired form. So carbon is having an allotropic form. This carbon nanotube is one of the allotropic form of that, because it is having a different form, the hexagonal, then cubical, and your diamond is a cubical crystal form. So this can help. The carbon tube has a lot of applications. Then nanorod is one such area is there. Yes, this I was talking about. The nanorobotics. Nanorobotics is one such area which is being now slowly entering into the medical field. Nowadays, most of the doctors are using a minimal surgery, minimum area that can be cut down, that can be exposed, that can be operated. So with the help of him, so that patient need not have to stay for a long time on the bed or in the hospital. So now people are thinking about developing nano robots of the size of 1.5 nanometer, like that, or little bit more, you can say that. So that nano robots can be smaller than even the size of the blood cell. You can see this is smaller. This robot is smaller than this. Because of course this is an imaginary picture, but in reality it will be coming very soon. So that the various things are drug delivery one such area, then biomedical instrumentation is one such area wherein we can develop. So there are certain applications in a medicine field, as we have discussed, energy area as we have discussed little bit. Then there are certain materials. Electronics is one such area where there is a lot of you can say that I'm skipping some slides because this I already discussed. Which can be we are using this. We know that when we started, because I remember Khalsa sir also we know him, that when sir has procured the first communication instrument, so that was like this conventional method, cable wire. So if we want to connect to some persons in some areas of the India or some person to the outside of India, then we have to book a trunk call. Nowadays we did not require. We can directly press the button and then we can talk to a person in America, talk to any person on any part of the earth. That is because of the technology, and the contribution of nanoscience is to a lot. There are two ways by which the nanotechnology that has contributed to the communication system or to the storage devices is the GMR and CMR technology, giant magnetoresistance and colossal magnetoresistance technology, because of which we can have. So we started because I also worked some maybe 25, 30 years back when I was in my first college, Danish Mahavidyalaya and Norga. There we used to start the computer. We have to boot the computer. We have to start the computer with the floppy. So we have to insert the floppy. That was a plastic. Then that has been changed to come to smart STD, and now we are using a pen drive. So that is all because of the GMR and CMR technology. So this is one such area of the medicine. The nano things is therapeutic application that we can use a small robotic kind of the thing to clean the mouth and etc. Destroy this kind of the thing. Then detection of the virus, that can also be possible with the help of, and by detecting the virus, because it is the need nowadays. The whole world is under fear because of the virus. So we need to develop this kind of the thing, and that is even possible. The transistor, as I told you, that these are the pictures of the transistor, earlier transistor, and now we can have the nano transistor, something like that. Okay, so this is of course a microscopic picture we can have. Yeah, this is what I was talking about, the storage devices. The hard disk, you can say that. You can see the size. And now if you compare today's with the pen drive, so which is very, very small. So earlier this 2 gigabyte hard drive, it was something about a 70 pound. And now we can procure that for hardly 2 pound or 3 pound. So that change that has been done. So in 2018, 2 gigabytes, so 80,000 rupees we have to, or $200 tag, and now in 2020 it has been reduced down to a lot. So you can compare this size and you can compare the pen drive size. Again, the pen drive size that has been come to a smaller size. So, and now if you consider this pin head, then we can store a lot of 1 terabyte data on the head of the pin. So this is how is possible. Then I think last few slides are there. So now we are developing the technology with the help of TiO2, titanium dioxide. So the foldable films that has been coming up very soon. So that earlier television set, TV set, which is having a CR tube, this big size, that has been reduced to a size of the book, and the displays are there, so that will be carrying because of the carbon nanotubes. Yeah, this is what you can say that is a foldable, and conducting films and panels are there. And in the mobile phone also, a lot of things are going on. As the time will be passing, so I'll be skipping that. Solar cell, which I already talked. So a lot of this in fabrics also, we can develop the fabrics in such a way that one shot we can have the different kind of the design on that simply by connecting to a mobile phone and giving the kind of the design that we want. Then on the same shirt we can wear that kind of thing. Then nanotechnology in the sunscreen, already I discussed. So I think, do we really need nanotechnology? Yes, we definitely need. Thank you very much. I'm sorry if I exceed my time. Hello, over to you, sir.
Hello. Thank you, sir. Thank you.
Thank you very much, sir. So it was an immense pleasure for us that you gave your precious time to us, and it was a very applicative talk of nanotechnology and its applications. Thank you very much, sir. Now I request participants that if you have any questions and queries, you can put in the chat box. You can raise your hand, or you can just unmute yourself and you can ask the question. So I think there are no questions in the chat box. So again, I am very thankful to Dr. Kishore Chandra Rewardkar, sir.
Hello.
Thank you.
Yes, sir. I think the principal sir is talking. Yes, sir.
Professor Kishore Rewardkar, sir. Sir, your talk is really very, very fruitful because you are explaining this particular nanotechnology and nanomaterials in a very simple way, so that the person, any person can easily understand. And you are telling us the wide application of nanotechnology and future of nanotechnology. So really it is very, very fruitful, and we clear our ideas. But still one question in my mind. Hello, am I audible? Is there any?
Yes, sir.
Is there any effects, adverse impact of the nanomaterials on the environment as well as human life?
Yeah, there is a lot of so science or any innovation is a brain or boon or anything, any discovery. It depends upon how we use it. Nowadays, just one simple example I would like to give, and I can stop because I know that we have exceeded the time schedule. Is that there is one technique that is called as the solvent auto-combustion technique, a synthesis of a nanomaterial, wherein we are using nitrates of some metal ions, and when mixing there, and finally when we converting that liquid into a kind of the nanoparticle, solid nanoparticle, that time a lot of gases are involved in, lot of gases are coming out of it. And these gases are very hazardous. Many students they don't know. So we need to take proper care there. So these gases are going into the atmosphere. So of course they are poisonous gases. So definitely they are artificially created. They are not naturally created. This is one such application. So wherein it will definitely create. And because at present the synthesis or this and that will be at the research level. But when it comes to the industrial level, definitely it will going to add to the pollution of the atmosphere for which we are fighting. So there are a lot of problems are there. And another thing, that the same material you can take, even you can take an example of a gold, which is yellow metal, which is called. But if you go at a nano level, smaller level, then you can have a gold of green color. You cannot even imagine in your wildest thought. You can have a gold of any color, any shade you can choose that. So likewise, and that is when we consider at a smaller level, like you can say that the homeopathic medicine, which is reduced to a potential level, but the concentration reduced, but its power that has been increased. So likewise, when we go to a nano level, definitely for a good application it is okay. But if we think in a different way, because after all it is a human brain, how we can utilize that. So definitely it is going to affect the atmosphere. So a lot of things are there, but I'm reducing it this discussion.
Right. Thank you, sir. Thank you. Professor Garvir, sir. Hello. Garvir, sir.
Over to you, Shashikant.
Sir, there is one question from one participant. The question is that what are the ill effects of nanotechnology?
Your voice is very feeble.
Okay, sir, there is one question from one participant. What are the ill effect of nanotechnology?
Ill effect of nanotechnology.
And can it be used with the tissues?
Can we use it with
tissues?
Tissue. Yes, definitely we can use with tissues. And there are, as I told you, it depends upon how a person can explore it. Whether the person wants to use this nanotechnology for the betterment of human health, for the betterment of human society, or to destroy that.
Hello.
Take a better example.
Hello.
Because of which we are suffering a lot from this lockdown. It is only because of China. People are now talking openly. So they have developed this same virus, SARS, SARS. It was already there. So they have introduced some DNA and RNA into it at a nano level. And now you can see the whole world is under pandemic. So there are definitely ill effects. But after all, like a bomb, atom bomb. So it was being used for the destroying the Hiroshima and Nagasaki. And it can be used. We are having the atomic centers in India, Kolkata. Then we are using this atom bomb, this atomic energy for the purpose of the developing the producing the electricity also. on that, there will be ill effects and there will be some good effects. So how we can explore that technology, it is up to we people. In almost all areas of the science people are using.
Thank you very much, sir, for the informative session. Over to Danveer, sir.
There was this technical issue because of which there was a shuffle in.
Because I am also unable to hear it.
Yes, sir, yes. Sir.
Okay, no problem.
Sir, am I audible now?
Whether I was audible to
Yes,
you
yes.
or
You are audible now.
Yes, sir. Some of the participants are eager to give you some online feedback, and some of them has voluntarily gave their name that they want to give feedback about this national seminar. So before that, I would like to thank you to the Dr. Kishore Chandra Revatkar sir for his precious time and his valuable presentation. Thank you very much, sir. On behalf of Mahatma Gandhi Arts, Science and Related to Commerce College, Armory, that we believe that in future too, we will definitely have a same kind of cooperation from your side, sir. Thank you very much.
okay, bye.
Thank you very much, sir. So on the voluntary suggestion, some of them want to give online feedback. So some names are there with me. I would like to call first Dr. Sanjay Gowri sir, who is from Dr. Ambedkar College, Chandrapur, Maharashtra. So Dr. Gowri sir is there?
Hello. Yes, sir.
Yes, yes, yes.
Yes,
Thank you,
sir.
Yes, sir. You can speak now.
Me, I audible?
Yeah. Gaudi sir, bola.
Yes. So I am Dr. Sanjay Gowri, Head and Assistant Professor in Department of Physics, Dr. Ambedkar College, Chandrapur. At the outset, I thanks the principal, Dr. Khalsa sir, and entire team of MG College, Armory for organizing this useful seminar, national e-seminar on advances in physical and mathematical science on Zoom platform in this pandemic situation. The first technical session was given by Dr. VNS Suresh sir on the topic Understanding Combating in Better Way, which is very relevant in this present situation. The second technical session was given by Dr. Vinod Varghese sir. His topic was Analysis and Fractional Order Model of COVID Pandemic with Non-Linear Incident Rate. The third technical session was given by Dr. A.J. Banpurkar sir. His topic of presentation was Spread of Diseases by Droplet from Coughing, Sneezing and Speech. The fourth technical session was given by Dr. Devendra Kumar Sahu sir. He is my best friend. He has given the talk on the electrical properties of conducting polymer of electrate state. Then the fifth technical session was given by Dr. K.S. Nisar sir. His topic of presentation was how to prepare the quality research papers. And the last technical session was given by Dr. Kishore Chandra Revatkar sir. He was my guide, and his topic of presentation was nanotechnology and its application. All the resource persons which are invited for the talk in this national e-seminar were extremely knowledgeable and expert in their fields, and they have linked their knowledge up to the great presenting style. It saw everyone captivated by the talk. I really enjoyed National e-seminar. This e-seminar was useful for the faculty, researchers, as well as PG students. I think overall this seminar is very successful. Further, all the staff of MG College Armory is very cooperative. Lastly, I thanks the entire team of MG College Armory, especially Dr. Shashikant Gedam sir, for giving me an opportunity to express my views in this national seminar. Thank you very much.
Thank you very much, sir.
Sir,
Thank you very much for your positive feedback, and you have rightly pointed out the relevance of this national seminar. The next feedback, the request came from the Nigeria, West Africa. That is Adam Sada. I request Adam Sada, sir, to kindly proceed with their feedback. It is feedback. Yes, Adam Sada, sir, is there? He has voluntarily requested for the feedback. I think he is there somewhere. I think we have lost the connection with him. Till then, the third request was from Dr. Sachin Dhavankar, sir. He is from Durg, Chhattisgarh. I request Dr. Sachin Dhavankar, sir, to proceed for the feedback.
Yeah, good afternoon. Hello.
Yes, sir, you are audible.
I am audible, no? Okay, good afternoon, one and all present in the session. Nice session is there. And I hopefully thanks to MG College, Arts, Science and Commerce College for giving me opportunity to share my view on the seminar, one-day national e-seminar on advance in physics and mathematical science. The session was very nice. I like the session. Overall session is very good. And whatever the idea shared by the persons who are being present in the seminar or given their talks is very fruitful for the present scenario. In the pandemic scenario, Dr. Suresh sir, Dr. Varghese sir, and Dr. Banpurkar sir has given the idea about the COVID-19 situation and what precaution we should be managed at this pandemic situation. I'm thankful for sharing his knowledge, those knowledge with each and everyone present at this seminar. Again, the polymer conducting material, the great new topic, smart material are there, which are been new topic for the researcher, and very generic topics that one can have lot of knowledge about the polymer conducting. The idea shared by the Sahu sir is great. The information is very fruitful, and the research knowledge given by the Nisar sir is very good and very nice. The talk given by the Nisar sir is very fruitful for the researcher, which are just beginning their ideas and try to publish their paper in the valuable journals. And the last but not the least, the talk by the Revatkar sir is on the nanotechnology, which is the advanced technology in today's world, is helpful to the each and every researcher who can have their ability to do the research to give the society the better quality of the knowledge. I congratulate Dr. L.H. Khalsa sir for organizing such a great e-conference. I also thanks Dr. Shashikant Gedam sir and whole entire team for organizing such an informative and fruitful conferences. Sorry, not seminars. I request Dr. Khalsa sir that in future we require such more information and more ideas about the today's world, what is happening in the today's world. So I request the Khalsa sir to just organize great conferences like this in future. Thank you.
Thank you very much, sir. Thank you very much, sir, for your valuable feedback. And I request all participants that if anybody wish to give feedback, you can just unmute yourself and you can speak up about the national seminar, about your experience and about the gain of your.
Hello, sir. Hello. Am I audible?
Yes, sir, you're audible. You're audible, sir.
Good evening, sir. It's me, Shwak Sinha from the Department of Chemistry. I am a student right now at Acharya Prafulla Chandra College in Ibarakpur. It has been really a very outstanding webinar, and I am really very privileged to be a part of such an outstanding initiative you have made. and I want in future to attend such more webinars to gain more knowledge about the physical and mathematical sciences. And I have a question. So if you allow me, so I can ask.
Yeah, yeah.
Actually, Saib, I want to know that what is the future job prospects in the field of the nanotechnology or the material science if I go to study or if I do research in the field?
The Revatkar sir is present.
Revatkar sir is there. No, I think we lost him. We lost his connection.
Okay, your question will be delivered to the Revatkar sir. And
Hello.
Can you sir tell it?
Yes, sir. Your question will be delivered to the Revatkar sir. Actually, we lost the connection with him.
Okay. No problem. Yeah. Okay.
Your question is very precious, and definitely we will try to satisfy it. Thank you very much, sir. Anybody else, if you want to give an online feedback, you can just unmute yourself and you can just speak up about the national conference. You can suggest some suggestions to us. So I think it's done. I'm thankful to all those participants who put forward their feedback for us. The feedback is very valuable, and definitely we are going to consider their suggestions in our future programs. Thank you very much to all. And now I would like to request Professor S.B. Gedam sir, who is an assistant professor and faculty of Department of Physics, Mahatma Gandhi Arts and Technical Commerce College, Armori, for the vote of thanks. Screen is over to Professor S.B. Gedam sir.
Thank you, sir. Am I audible, sir?
Yeah.
Thank you, sir. मनोहरभाई शिक्षण प्रसारक मंडल आर्मोरीज, महात्मा गांधी आर्ट साइंस एंड लेट नसरुद्दीन भाई पंचवानी कॉमर्स कॉलेज आर्मोरीज, डिस्ट्रिक्ट Gadchiroli, Department of Physics and Math has organized this one-day national e-seminar on advances in physical and mathematical science. Today, a very special day, as remarked by Dr. Varghese sir, that is 10/10/2020, that is the 10th October 2020. This is the last moment for our this e-seminar, and I am here to propose the vote of thanks. This e-seminar on advances in physical and mathematical science has been extremely fruitful in discussing various aspects of COVID-19 pandemic. After that, analysis of fractional order model of COVID-19 pandemic with a non-linear incident rate, spread of diseases of droplet and aerosol. After that, conducting polymer quality research paper, nanotechnology and its applications. For this useful and scholarly e-seminar, we had a chairman and our inspiration principal, Dr. Lal Singh Khalsa sir. I am grateful to Dr. L.H. Khalsa sir for his brief welcome speech and inspiring us. After that, I am thankful to Dr. K.S. Nisar sir, Professor, Department of Mathematics, College of Arts and Science, Wadi, Al Waizara, Saudi Arabia, who effectively talked on how to prepare quality research paper as well as greatness of group work. I am grateful to Dr. Kishore Chandra Revatkar sir, Professor and Head of the Department of Physics, Dr. Ambedkar College, Dikshabhumi, Nagpur. His talk on nanotechnology and its applications was thought-provoking and valuable for all physics and mathematics teaching fraternity. I am also thankful to Dr. Devendra Kumar Sahu, Professor, Department of Physics, PG Government College, Lalitpur, Jhansi, Uttar Pradesh, for his useful talk on electrical properties of conducting polymer in electric state. Thank you, sir. Thank you very much, Sahu sir. After that, I am extremely thankful to Dr. A.G. Banpurkar sir, Professor, Department of Physics, Savitribai Phule, Pune University, Pune, for this brilliant speech on spread of diseases by droplet and aerosol, physics of droplet for coughing, from coughing, sneezing, and speech. Also, sir very well explained process of sedimentation. I am very much thankful to Dr. Banpurkar sir. I am grateful to Dr. Vinod Varghese sir, Associate Professor, Department of Mathematics, SR Bharati College, Arni, Yavatamal, for his valuable discourse on analysis of fractional order model of COVID-19 pandemic with non-linear incident rate. I am also propose vote of thanks to Dr. VNS Suresh sir, Associate Professor of Dr. Ambedkar College, Diksha Bhumi, Nagpur, for his brilliant talk on COVID, that is 19, understanding becoming in better ways. I am thankful to our head of the Department of Physics of our college, Dr. Thomre sir, Dr. C.D. Mungbode sir, and our technical team in that Professor Priyadarshan Ganvir, Professor Sunil Chute, Professor Dr. Satish Kola, Professor Dr. Kishore Vasurke, for their technical support, without where we cannot conduct this e-seminar possibly successful. I am thankful to all participants of this e-seminar who actively participate in every activities of this seminar. We have given the name here, the e-seminar for the national, but the participant, more than 25 were from out of India, they are abroad from this. That means we can say that this, this was the international e-seminar also. I am thankful to all those who have directly, indirectly support us for the successful organization of this e-seminar. Now, with the permission of our chairman of e-seminar, Principal Dr. Lal Singh Khalsa sir, I declare that this one-day seminar is on advance in physical and mathematical science is over. Thank you very much, sir.